left over.
I don't want to get one.
Okay, well, do or do not.
So that means I probably should.
Yeah. I'm guessing everybody else is coming to the Monday review for you guys.
Did you like my analogy before
Tuesday.
I left yesterday?
Yeah, Tuesday.
What analogy?
About the clown cars?
Yes, I thought that was top notch.
You've seen Mr. Deeds, right?
I have, yeah.
Remember how he writes the cars?
Right.
Start writing analogies.
Do it.
Wait, what time is our thing on Tuesday?
I thought it was Tuesday right after school, but I could be wrong.
Because
Oh, yeah.
we kind of have to meet.
According to Miss Howard, we're not gonna have school Monday.
Who?
Miss Howard, she says we might not have school Monday because of the snow.
Is there a bunch of snow
But
coming in?
we never cancel for snow. We 15 inches, they make us come. But,
The buses
she
can't get through.
said
Yeah.
that if they cancel Monday and we have school Friday, it still has to be a makeup day because Friday doesn't count as a real day.
No, I don't know. I would trust Howard. She's pretty on top of stuff. Stupid doesn't mean it's not real.
I mean, she's been reading the same books for 20-something years.
I suppose so.
That tells you something.
What's she like as a teacher?
If you like,
Yeah.
she's calm, and when she gets mad, she doesn't get mad.
Gets calmer.
She's like, she tells you in an intelligent way that you're stupid and you need to knock it off. But no one realizes, like, I don't know.
Rad. Sat next to her for a parent-teacher conference. You got to know her a little bit. She seems like a cool person. Listens to a lot of cool music. What?
Does your car
Coolant? I hope so.
If it doesn't, then that's probably why your heat's messed
I know.
That's what I thought. I'm pretty sure I've had that checked recently, but I will double check that this weekend. Thanks for the heads up, though. I hope it's that. Easy fix. All right. Let's rock and roll.
Maybe it's just saying you need to get a new car.
You what? Oh, well, I can't get a new car, so if that were to happen, you might have a new teacher next semester.
Why don't you just take it to the dealer or something?
Is that expensive?
That will cost money and time, which I do not have because I'm here.
Go find me. Yeah, 'cause
Yep, please. All right, so first page algebra review. How do we feel about sets?
Hold up. I got geometry. So sorry. Yours not sets.
Maybe if you grab the one that looks like the one on the board.
Yeah, you can get the one.
Yeah, good job, guys. Berate them. Good job. Go get them.
Why do you have two staples on this?
That one, because I stapled it and realized there were some pages left behind.
Oh, way to go.
Well, Hana means family.
No, he's just super tired.
All right, so
Go.
that's right. So, first page. How do we feel about sets of numbers?
I gotta go over that one.
Okay, well, everything in here first semester is a real number. We'll be getting to numbers that aren't real eventually. Then I like starting from the bottom. By the bottom, I mean the natural numbers. Basically, it's either rational or irrational, right? It's one or the other. So we're going to start from here and work our way up. The reason for that is because this is the smallest set, right? It's the fewest number of numbers that fit in here.
So one's above 0.
Right, so natural numbers are numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., right? Ones you'd count your sheep with, natural, right? And does not include 0, because 0 is a whole number that was actually invented a little bit later by the Chinese. So, which ones are natural numbers? Looks like nothing here except for the root of 4, which is, of course, 2, right? That's the only curveball I can really throw at you there. If you know what natural numbers are, that's the curveball, right? I could give you a root that actually simplifies because root 4 is 2, which makes it natural, right? Cool. All right, whole numbers. So it's all the numbers from before and 0. So it'll include this one because it's a number from before, right? It includes all the natural numbers plus 0. So if we have a 0 here, then we mark as well. Yep, we do. So any number we marked here plus 0 is what's going to happen, right? So this is a slightly bigger set of numbers. It's bigger by one number. Integers, in theory, doubles it, right? Because we're going from the natural numbers, which are 1, 2, 3, 4, 5, 6. And now the integers are including the flips of those. -1, -2, -3, -4, -5, -6. So it's going to be anything from before is included in this, right? It kind of overlaps like a Venn diagram. But it also includes negative versions of those numbers. So -8 is a negative whole number, right? So it's going to be an integer. None of the rest fit. So now we debate rational or irrational. And rational, there's two ways to talk about this. So we're either talking about a number that terminates, and to terminate means to stop, right, to finish, or repeats. And by repeats, I don't mean goes on forever. I mean repeats, meaning it goes on forever and has a pattern to it, right? So terminate means it stops. Repeats means that it goes on forever with a pattern, right? So -8 stops. It stops right there, -8 point, right? We're done. So again, anything from before is going to be included in this because this is the biggest set of numbers that we've dealt with so far. 0 stops, right? And 2 stops. They are finite numbers in length. So everything from before fits that definition. And then there's also new numbers like 0.219 repeating, right? It repeats. It has a pattern. So we're going to check that one. Pi goes on forever, so it doesn't terminate. Does it repeat? Pi does not repeat. It has no pattern to it, which is why we're not able to draw a bar over it and write it out, right? It goes on forever with no pattern, so we call that irrational. -1/3. Well, there's another way to look at rational numbers, right? And you're right, it does repeat because it's -0.3 repeating, right, is what that would be. So it does repeat, right? But there's another way to think about it as well. If your number can be written as a fraction of 2 integers. So how I'm going to write is this. P over Q, where P exists in the integers and Q exists in the integers. So if this, then let's say A. Then A exists in the rational numbers. So let me tell you what this says. If your number A can be written as a number over another number, and those two numbers are integers, so negative or positive whole numbers, right? Then A is rational. So check it out. If you look at this number here, -1/3, the top number is -1, the bottom number is 3. So the top number is P, and the bottom number is Q. Is -1 an integer? Yeah, -1's an integer, right? It's a negative whole number, right? Is 3 an integer? Yeah, it's a whole number, right? It's an integer. So if we have integer over an integer, then it's rational. That's another way to think about it. So any number you can write as a fraction where the top and bottom number are integers, you're good to go. Now the reason we have to say where the top and bottom number are integers is because technically, right, any number is a fraction, right? I can take pi, put it over 1. That's a fraction, right? But that is not an integer, or not a rational number, because pi is not an integer, right? The top number here isn't an integer. So that doesn't count. So again, let's go over these guys before we fill out the rest of this. Natural numbers are numbers you count your sheep with, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whole numbers are all those numbers plus 0. Integers are all those numbers plus their negatives, right? And then the rational numbers are any number that terminates or repeats, or another way to think of it is you can write it as a fraction where the top and bottom number are integers. So it's really important to know what the integers are. So Baker, what is an integer? Yeah, so it's like a natural number and their negatives, right? So if I have a number written as a natural number or their negative in the top and the bottom, then that's rational, right? Two ways to think about it. Terminates or repeats. This one repeats, 0.3 repeating, right? But it also is an integer over an integer. This one down here, -0.9991, is that a rational number? Why? It terminates, right? Also, fitting the other definition of being P over Q, it has to fit that as well, right? I mean, if it does one, it should do the other. How would you write that as a fraction? Well, I'd write it like this, 9991 over 10,000. When you do that, that'll give you this. Negative, of course, for this example, right? right? If you divide something by 10, it moves the decimal place over. So if you divide it by 10,000, it's going to move it all the way over to here. Right. So it can be written as P over Q, where P and Q are integers. Then root 2 over 2. Is it a rational number? Nope, it's irrational. Root 2 cannot be written as this, right? The top number needs to be an integer, and root 2 is not an integer, right? So nope, it's irrational. Also, if you did root 2 as a decimal, it would go on forever with no pattern. So when you divide it by 2, it still goes on forever, no pattern, just half as big. How do you feel about that? As you can see, the biggest set is the real numbers. It includes pretty much everything we deal with, right? The next biggest set is the rational number. It includes almost all numbers, right, except for the irrationals. Then we have integers, which includes a good amount of numbers, right, on average. Whole numbers, pretty selective. Natural numbers are definitely the most selective, right? There's very few numbers that fit natural numbers, right? If you were to take a dartboard and fill it with all the numbers, all the real numbers, and you threw a dart, the odds of hitting a natural number, astronomically impossible, right? To hit 3 on the dot, 4 on the dot, 6 on the dot, right? Odds are going to be slightly off. In fact, what's really fun to think about is that if you had all the numbers on a dartboard and you threw a dart, it would be astronomically impossible to hit any number, actually, because they're all like one out of infinitely many, right? So if you said, I'm going to try and hit 3, I'm going to try to hit pi, I'm going to try to hit anything, it'd be astronomically impossible. However, at the same time, you would be guaranteed to hit at least one number. So it's astronomically impossible to hit one, but you're also guaranteed to hit one, right? Infinity's weird. All right, next one. Let's talk about this. 10, 11, 12. So negative 6 squared. So there are distinctions to be made here. Exponents come before multiplication in PEMDAS, right? And PEMDAS mostly is a lie, but it is a general guiding principle. So that negative in front of there really means we're going to take negative 1 and times it by 6 squared. That's really what that means. Whenever there's a negative in front of a number, it means that number times negative 1. Okay? So what's happening here is multiplication. And then we have an exponent. And we said exponents happen first, right? So that means we get this first. And then we get negative 36 as our answer. Yes?
Can you do it? Wait. Never mind.
So if you were to type that in a calculator, you get negative 36. And you'd be like, what the heck? A negative times a negative is a positive. And the calculator, in its absent voice, would try to tell you, you idiot, negatives happen after we square. Because it's multiplication, right? Now imagine this problem was this. Negative 6 in parentheses squared. Well, what happens first? Parentheses are exponents. Parentheses, right? So we do negative 6 first. So we take negative 6. It's been negative 6i'd, right? And then we're going to square this. So we get 36. I know I wrote the same thing twice. But yeah, we get 36. It's a negative 6 times itself. Okay?
That goes for 11.
So looking at 11, 6 to the negative second power. So this is a whole different concept, negative powers, right? So let's talk about what those mean and why they are what they are. Again, we've learned this already in the year, but you might have forgotten it. So what a negative power means is this. And we can do this logically. Okay? So let me get a piece of graph paper. And I'll walk you through the idea of negative exponents. Like, it seems really weird when you learn like what they do. And you're like, well, that's random. Until you realize that it actually fits the pattern.
Doesn't it flip the reciprocal?
It does. It has to do with the reciprocal. The question is why, right? So the answer to this, just so you know, is 1 over 36. That's the answer. Now, why is that the answer is the more interesting question. So let's take a look at 2. If we do 2 squared, what's 2 squared? 4. Pretty straightforward, right? It's 2 times 2, and that gets us 4, right? 2 times itself. And if we do 2 cubed, what's that going to be? It's going to be 8 because it's 2 times 2 times 2. 2 times itself 3 times equals 8. And this is what they teach you when you're younger, right? Then 2 to the 4th. We have 2 times itself 4 times, right? So it's 8 times 2 is really what it is, right? This is 8, and we're timesing it by 2. That's going to be 16. And so on and so forth, right? Well, by that logic, what should 2 to the 1st be? 2, right? Because it's just 2. And that's it, right? 2. There's our answer. 2 to the 0th. 0. 1. What? The answer is 1. Why? You think no 2's, right? 0. Well, it turns out the rule they taught you about this in basic algebra in middle school isn't actually the full rule. What they're leaving out is this really important detail. 2 to the first means 2 times 1. 2 squared means 2 times 2 times 1. 2 cubed means 2 times 2 times 2 times 1. And 2 times 2 times 2 times 2 times 1 is 2 to the 4th. So 2 to the 0th power is 1 because it's 1 times nothing. 1. Not 0, but times nothing, right? Don't do anything to it. They leave it out because you never deal with 0th powers, right? You barely even deal with 2 to the 1st, right? And so they just teach you the quick trick. No one wants to say times 1. Don't forget that. And you're going to go, why? And then they have to explain all this crap. And they don't want to do that, right? I don't know why, but they don't. So they just say, look, 2 squared is 2 times 2. 2 cubed is 2 times 2 times 2, right? Leaving out the 1, because 1 shouldn't change anything. But it does when we start getting to 0. Now, using this logic, 2 to the negative first power. Why does it equal a half? Why? Why does it equal a half? Boom. 1 divided by 2. Nice job. Brilliant. So we take 1, like we always do, but instead of timesing it by 2, which is what 2 to the first means, right? We're undoing a times. How do we undo times? Division. So 2 to the negative second would be take 1 and divide it by 2 twice, right? Quarter. Makes sense, doesn't it? And if you notice the pattern, 2 to the first is 2. 2 to the negative first is 1 over 2. So it's the reciprocal, right? 2 squared is 4, so 2 to the negative second is 1 over 4. 2 cubed is 8, so 2 to the negative third should be 1/8, the reciprocal of the answer from before, right? Which is true. Divide by 2 3 times. Make sense? That's what's going on. Baker, how do you feel? Mind blown? Makes a lot of sense, doesn't it? And that's how math should feel. When they teach you this stuff, it makes sense. But then it screws you over down here, and so what teachers have you do is just memorize, right? You just flip it. It's the reciprocal. Why? I don't know. And then when you forget that it's the reciprocal, you're screwed. You see something like this, and you go, oh my God, right? So check it out. 6 to the negative second. How I would show my work for this is I'd say, well, it means take 1 and divide it by 6 twice. Well, that's 1 over 36. The next one. Any predictions on what the answer will be? Prediction that the answer is going to be positive. Why do you say positive, Troy? 2 negatives make a positive, right? This is another thing your teachers tell you. 2 negatives make a positive. They don't tell you how they make a positive, right? So whenever you see 2 negative numbers, you're inclined to say, oh, positive answer. No, 2 negative numbers when they multiply or divide make a positive number. 2 negative numbers when you add them make a negative number, right? 2 negative numbers when you subtract them might make a positive number, might make a negative number. Depends on which one's bigger, right? The negative sign for exponents has nothing to do with that. All it means is we're going to divide by negative 6 twice. So we take 1, and we're going to divide it by negative 6 twice. And how do I know we're dividing by negative 6? Well, negative 6 is wrapped in parentheses. See how it's parentheses down here? What's negative 6 times negative 6, Troy? It's going to be positive. It's going to be positive, right? So 1 over 36. These are the same. Dividing by 6 twice is the same thing as dividing by negative 6 twice because the negatives cancel, right? Now, what if they had given you this? Would it be the same answer? It wouldn't. We're going to take 1, and we're going to divide it by 6 twice. And we're going to times it by -1. That's what that minus means, right? Remember from earlier? Times by -1, square 6. Times by -1, and divide by 6 twice. We need a name for undivide, or unmultiply by 6. So divide by 6 twice. Maybe. When you multiply by 6 twice, we call it squaring it, right? What's unmultiplying by 6 called? Well, divide by 6 twice, that's kind of a handful. Need a better name. Maybe there is.
The Mac division.
Whoa. How do you feel about that answer for this one? Does that make sense to you? Okay. Being able to explain this is important. 13. Circle each term and underline each coefficient. Then combine like terms to simplify the polynomial expression. Well, first of all, let's talk about what these things mean. What is a term? X is an example of a term, but so is 7. So is x times y. So is -3/4 x. So is -1,000. What are terms? Nobody knows? Well, terms are pieces of an expression, right? So there's a piece, x squared. And then there's a piece, a -8. And there's a piece, 6x. And there's a piece, 3x squared. And there's another piece, 11. And another piece, and another piece. Now, how would we define a term? Because pieces of an expression is pretty loose, right? How do I know this is a piece? X squared. And 3x squared is a piece and not 3 and x squared as separate pieces. How do I know that that 3 is not a separate piece from the x squared? What do you think? Why didn't I circle the 3 separately from the x squared? It's combined by what? What? Well, the 3 is combined with the x squared. How are they combined? Multiplication. So here's what a term is. Anything in an expression that's separated by a plus or a minus. Make sense? Multiplication does not count as separation, right? They're together, right? Same thing with division. Even though they're apart, they're still considered one term, an idea, okay? So these are separate ideas being strung together by addition or subtraction. That's what terms are, okay? Coefficients, or an underline. Coefficients are numbers that are being multiplied to something else. So see this variable right here? It's multiplied by 3. So 3 is a coefficient. So is 2. Technically, there's a coefficient in front of x squared and x. What's the coefficient in front of x squared and x? 1, right? Coefficient of 1. But we're not going to underline it because it's not there, right? It doesn't appear there. Technically, there's a coefficient, and technically 8 and 11 are coefficients as well. They're coefficients of x to the 0th power. What's something to the 0th power? Nope. Something to the 0th. It's 1, right? It's 1 times 0 of that thing, right? Which is 0 or 1. So we have 8 times x to the 0th here. They just didn't write x to the 0th because x to the 0th is 1, right? So technically 8 is a coefficient as well, but we're going to call it a constant instead. A number that's always the same. 8 is the same, right? A variable would be like x, right? Changes depending on what the situation is. 8 is always 8. 6 is also a coefficient. How do we feel about coefficients? Numbers in front of variables, right? Terms, anything separated by a plus or minus. It says combine like terms to simplify the polynomial expression. Well, expressions are anything without an equal sign, right? We got it right here. Polynomial has multiple terms, right? So many terms. A binomial is something with 2 terms, like x plus 2. A polynomial is when we have lots of terms. So now we're going to combine them to simplify it, right? Get fewer terms. So, Troy, what terms can I combine here? Give me two terms I can put together.
6x and x.
6x and x. So we have negative 6x plus an x. So it's going to be what? Those two make negative 5x. Make sense? They're like terms because they're both x's, right? Again, terrible idea in real life, great idea in math is to get our x's together, right? Isaiah, give me another two terms I can combine. Negative 8 and 11. They're both constant terms, right? We can put those together. We do that all the time. So that's going to be 3. Hanging in there, Troy? Baker, give me another two terms I can put together.
Yeah, Baker.
Yeah, I'm talking to you. I call him Troy.
X to the second power and 2x.
Okay, so we have x squared and 2x squared, and they combine to how many x squareds? 3x squareds. So we've done all of these as a partner, except for negative 3x squared. Can we combine negative 3x squared with something as well? Yeah, we can. So we can do this. And what's left over? Absolutely nothing. So the simplest way to write this would be as a binomial. 3 minus 5x. Or if you want, right, negative 5x plus 3. Right, it's like you're taking a process that has lots of steps. Take x and square it, then subtract 8, then subtract 6 times whatever x is, then subtract 3 times x squared, then add 11, then add x, then add 2x squared, right? Or you could just take 3 and subtract 5x, right? It gets you the same spot. So we call that simpler. It has fewer terms, fewer instructions, fewer steps. How you feel combining like terms? Hard? Tired, oh, got it. I'll take that. Tired is temporary. I was exhausted. I went to bed at like 8 last night, and I woke up at 11 this morning. Whew, very tired. What?
It's over like 10 hours of sleep.
It's way over 10 hours of
They say
sleep.
The more you sleep, the tireder you are.
Can be sometimes. Also, make up sleep requires a lot more sleep to make up for lost sleep. All right, so here we are. Simplify each expression. This is an expression because it has no equal sign. So, stuff in parentheses we should probably do first. Let's simplify this 5 plus 5. What's 5 plus 5? 10. Good. And then it says negate it, so negative 10. Then it says divide by 5 times 2. Okay, so we're going to divide by 10. Now, does that minus 1 go underneath here with the 10? No, it does not because it's a separate term. So then we're going to subtract 1. And then it says divide that 1 by all that stuff. Does all that stuff go underneath the bar, or does it not? It does because it's wrapped in parentheses to be all one idea. So we have 1 divided by 2 minus 3 over 3. Well, 3 over 3 I'm supposed to write like this. So let me write that out a little bit nicer. We said negative 5 plus 5, so that's going to be negative 10. Then we divide that by 10. Then we're going to subtract 1 over all of that stuff. Minus, and you'll notice that inside this term is another term, 3 divided by 3. So parentheses not only say, hey, do this first, but they say, hey, this is an idea. This is a term. Treat it like a term, okay? So we have one idea divided by another idea minus one idea divided by another idea with an idea inside it. Ideaception, right? Ball. Right? You've seen the movie DiCaprio, Inception. No?
Yeah.
Go home and watch it. It's a dream within a dream within a dream within a dream. Are we cool with this setup? Does that make sense of how I got there? If it doesn't, let's talk about it. Does this make sense how I got there? Okay. Negative idea divided by an idea minus another idea divided by another idea. And that 3 divided by 3 is its own idea. Cool. So now let's simplify. What's negative 10 divided by 10?
1. Negative 1.
Very good. And then we're going to subtract whatever 1 divided by 2 minus 3 over 3 is. Well, what's 3 minus 3? 1.
Well, 3
3 divided by 3. My bad. Negative 1 minus 1 over 2 minus 1, which is 1. What's 1 divided by 1? 1. Negative 2. All that, negative 2. Kind of disappointing, right? All that for nothing. Look at number 15. Yikes. All right, so let's highlight some ideas here. Let's talk terms. So this one thing should all be treated as one idea because it's in parentheses, right? And then we have another thing that should be all treated as an idea. Within those ideas, we have ideas. This guy is one term, right? And this guy's a term. Of course, this is also a term. And this is a term. And this is a term. And this is a term. Right? And lastly, this is a term. They're all terms, right? But we have the two big ideas. That's what those parentheses mean. So let's take care of these terms inside the parentheses. So look at this first one in maroon. Mauve, chartreuse, burgundy. Negative 3 squared, not the quantity of negative 3 squared, right? No parentheses here. So what is that going to be? Negative 9, because it's 3 squared, then we negate it. You with me? How about here in dark blue? What's minus 9? Well, it's minus 9. Take 9 and negate it, right? Minus 9. Next one in purple. It says the quantity of negative 3 squared. What's that going to be?
9.
Positive 9, right? Because it takes negative 3 and times it by itself, right? 2 negatives make a positive. This one said take 3 and square it, right? And then negate it. That's the difference between these two. 3, then square, then negate. This says negate, then square. So negative 3 times itself is positive 9. 3 times itself is 9. Then you negate it, negative 9. In the light green, what's 3 squared? 9, right? 9, 9, 9, 9! What's 2 times 3? What's 2 times 3? And then positive 5 is just positive 5. Right? We'll simplify that later. And then we're supposed to subtract whatever 6 times 2 to the negative first is. Well, that's 6 times whatever 2 to the negative first is. Let's figure that out. What's 2 to the negative first?
There's a person outdoors.
There is? Who? And which door? Who?
CJ.
CJ. All right. What's 2 to the negative first? Yeah, go for it, please. Thank you. What's 2 to the negative first? What's 2 to the negative first? Yes, you do. What's 2 to the 0th?
Negative 2.
Nope. What's 2 to the 0th power? 1. How do we get there? Right? We're undoing 2's. So look back here. Right? To go backwards, we undo a 2 each time. Right? How do I undo a 2 from 1? I divide by 2. Half. Or the reciprocal. Right? So now let's do some math. What's negative 9 minus 9 plus 9 plus 9? 0. Who cares what this is? It'll be 0, right? Because 0 times anything is 0. But let's do some math for fun. We've got 6 plus 5, which is 11. Then we're going to subtract half of 6. 3. Hey, what up?
Yeah.
Got a review packet?
Yeah.
Awesome. I like your shirt.
Thanks.
It's rad. Keep going.
Stop.
Rearrange each equation solving for each variable. Want me to go through these or no?
Yes.
All right, we have a yes.
It's easy, but
So solving for x, I got to get rid of the 1 and the 2, right? Do I care about this stuff? Do I care about any of that? No, I don't, right? So I'm just going to get rid of the 1 and the 2. To get rid of the 1, I subtract, and to get rid of the 2, I divide. We always save divorce for the last option, right? That's division, right? If you divide, you have to divide everything by 2, right? And that's going to make that a half, and then 3 halves, and negative 5 halves. I'd rather not create fractions, so that's why I save division for last, right? Because if I'm going to get fractions, I'd rather it be my last step, right? And then just circle it instead of having to move them around afterwards. So what I'm going to do is I'm going to subtract 1 first. Again, you can do whatever you want. But I'm going to subtract 1 first and keep everything not divided up. And I'm going to get 3y minus 6. And then when I divide, yeah, I'm going to get a fraction. But at least I'm done, right? And again, when you divide everything. And divorce, everything gets split. I just watched Marriage Story last night. You guys watch that yet with Adam Driver and Scarlett Johansson? Spoilers, they get divorced. All right. Let's find y now. So starting with the same equation, I'm going to get y on its own. I need to get rid of the minus 5 and divide it by 3. Could I divide by 3 first? Sure. But we get fractions here, so I'd rather not do that first. Let's subtract 5 first. When I do that, I get 2x minus 4 equals 3y. And then divide everything by 3. And again, I'm going to get fractions here, but at least I'm done. How do you feel? Oops, I have 2 x's here. How do you feel? CJ, you sure you have one?
No.
If you don't, just grab a new one. You haven't written anything on it, have you?
No.
Yeah, just grab a new one. Make sure you get the algebra one. We're on page 3, number 17. Yeah. 2x plus 3. Plus 6 over what? Over 3. Well, is 2 divided by 3 2/3?
Yeah.
And is 6 divided by 6 divided by 3? Is that what we had?
Yeah.
I'm an idiot. Add 5, you get 6 here. Good call. Sorry. It's going to be a long one, guys. I tried to get as much sleep as possible last night. Hopefully I won't make mistakes. We could simplify that further, right? Because 6 divided by 3 is 2. Up to you. Huh? Yeah, works for me. Or you can have this when I'm done with it, right? Not the whole thing. I probably would want to keep it, but
You're just waiting for the part that's on the test. Then you can take a picture.
that's right. All right, so getting stuff on its own. Let's do the next one. Yes or no?
Yeah.
Okay. So we want to get x and y on their own because we want to get x on its own and y on its own separately. So first thing I'm going to do is actually, we have a p here as well. How about we get p on its own first? So what do I do to get p on its own? What do? It's 2 times p.
You erase everything.
No.
What?
Yeah, I divide to get p on its own. So I'm going to divide by 2. Now, this is not as scary as you think. When I divide something in 2, here's something, right? Here's something. I'm going to divide it in 2. Cool? Now, if I have something that's divided by 2, and then I divide it by 9, right? It's already being divided by 9. Then I'm going to divide it by 2. So if I divide it by 9, and then divide it by 2, I get a total of 18 pieces. Trust me on that. My drawing's terrible, but 18 pieces. So something divided by 9 and then divided by 2 is going to be the same thing as something divided by 18. And we're done. Another way to think of that is it's something divided by 9 and then divided by 2. Right? Just like when we divided by 6 twice the other time, right? We had divide by 6 down there, right? We have divide by 9, divide by 2. Well, what is 9 times 2? 18, right? Now let's get x on its own. So I need to get rid of the y and the divides by 9. Whenever I do stuff, I try to get rid of division first. So I'm going to do that. So I take x times y divided by 9. I'm going to multiply that by 9. So I get xy equals 9 times 2 times p. Well, what's 9 times 2?
18.
Good. So I went from there to there. Now I want to get x on its own. So how do I get rid of the y? What's going on between x and y? Multiplication, right? Multiplication. So what do I need to do to split them up? Division. So I divide by y. 18p divided by y. That's x. Now from that same spot, I could very easily get y on its own, right? What would I do? Yeah, divide by x, right? Done. Let's look at 18. So, what do you want to get on its own first? How about p? I have to add the y and add the x, don't I? So I'm going to do that. P equals whatever's already over there, plus the x, plus the y. Done.
That's easy. I was thinking
How do I get the x on its own? Add the y, subtract the p, and then times by -1. I'm going to do that. So we have negative x equals 4/9. We're going to subtract the p over here, and we're going to add the y over. Now I divide everything by -1, and I get this. Basically, it just changes all the signs, right? We multiply or divide by -1. To negate something needs to change the sign. So I negated x by making it positive. I negated this and that. Negate everything. Y is going to be the same story. It's just going to be, we have negative y equals 4/9 plus x minus p. And when I negate everything, I get y, negative 4/9, negative x, and positive p. How you feel? Good? All right. 19. All right, so the trick here is to think of this as an idea. We have p divided by 2. Let's pretend that. If I had p divided by 2 equals 5, how would you solve? Multiply by 2. Well, we have p divided by x minus y. So I'm going to multiply by x minus y. Now, when I do so, because there's two terms there, right, separated by a minus, I have to wrap them in parentheses. So I get this. Because p was on the right. You'd rather have the 5 out front. You could do 5 times the quantity of x minus y. Both are valid. You could also have 5x minus 5y equals p. Right? You can distribute or not. Once I get p on its own, I just circle it. Right? That was the goal. Why work harder? Who cares? Now let's get x and y on its own. So what I'm going to do is I'm actually going to move the x and y. The thing that I want to get on its own, I'm actually going to move. Normally I leave that alone, right? Leave x, move everything else, right? But I'm going to move that over because when I move it over, I get this, right? So I move it over, and now I'm going to divide by 5 to get rid of the 5. So I get x minus y equals p divided by 5. Now which one do you want to get on its own, x or y? We don't need the parentheses anymore, right? So I got rid of them. So let's get x on its own. We add y. So we take p over 5, and we add y to it. It doesn't go up top. It doesn't go on the bottom. It goes on the side, right? This is a term. We're adding another term to it. 2 terms. Getting y on its own, I'm here. Minus x. Then I negate everything. How you feel? Good? Schlaffer, you learning a lot of algebra? Nice. Honestly, I wish all my geometry kids would come to this. Help them out a lot. Guys, I'm here for you, so you tell me what you need. 20. Keep going? You want to finish it? You want to finish your test?
Yeah.
Then do it.
Wait for an intermission to ask a question.
What's your question?
Well, it's on this, so just do your thing, and then when you come to a break, I'll ask.
All right. You got time?
I've got all day. What kind?
You want to see any more or no?
I'm not sure.
20, 21, 22? We can always skip, come back later.
Yeah.
Assert yourself, okay? Because as soon as I get people saying I don't want to be here anymore, then I'll say great, go away, and I'll go like do something on my computer or something, right? So make sure you are taking advantage of this time and saying, hey, I want to see this. If one of you wants to see it, that's good enough for me. There's only 4 of you in here, right? In Schlaffer. So let's skip 20 through 22 if we're cool with that. We're gonna skip it for now? Okay. Moving on. 23 through 26. Want to see them? It's more of the same. No? Okay, we'll skip those concepts. Skip 23 through 29. Skip. Let's go 30 through 33, though. That's on page 7. That's slightly different. This is talking about how to multiply fractions. Do we need common denominators to multiply fractions? No. Right? It's only addition and subtraction, right? Combining terms, right? We can only combine them if they're like, and if their denominators aren't the same, then they're not like terms, right? So we need to add and subtract with common denominators. But for multiplication, ain't no thing. Remember, fractions are division for lazy people. So really what this says is 3 divided by 4 times 24. And we can do multiplication division in any order we want. So how about we do 24 divided by 4 first? What's 24 divided by 4?
6.
Then we times it by 3 and get 18. So what I did was I did 24 divided by 4 and got 6. And then I got 18. Is that confusing? I know, right? It's that easy. Why have people not been teaching you this? I guarantee 5 years of me saying, hey, division is just fractions are just division for lazy people, right? You'd get it eventually. But yet we have 5 years of elementary school and middle school where we're learning fractions, and you guys never talk about that. I don't get it. So 31 is just saying 2 divided by 3 times 12. Again, do it in any order you want. You want to do 12 times 2 first? Great, 24. Divided by 3, 8. You want to do 12 divided by 3 first? Great. What's 12 divided by 3? Times 2, 8. If you want to be really crazy, 2 divided by 3 is 2/3 times 12. Well, 2/3 of 12 is 8, because 1/3 of 12 is 4. So 2/3 is going to be 8, right? Wouldn't recommend that method, but yeah. So what do you want to do? Divide first or times first?
Divide.
Okay. So we get 2 times 12 divided by 3, which is 4. So it's 8. 2/3 of 12. You do that in your head, people think you're a freaking genius. It's not hard. You just need to know what to do. Most people just have never been taught. Or they didn't pay attention. Another way we could have done it. 24 divided by 3, right? 12 times 2 is 24. Divided by 3 is 24 over 3. And we can reduce that. 24 divided by 3 is 8. Yeah.
If I just like cross out that and make that sit, like so.
Showing your work.
Yeah, so like we're on 31. If I just crossed out the 3 and the 12, made the 12 4.
Yeah, that's fine.
And just had the answer.
That's fine.
Be fine on the test.
Yeah. I just want you to know it's not canceling anything. I hate the word cancel. It means absolutely nothing. It's not a math term. People use that. And sometimes they cancel and you get 1. Like 4 divided by 4 cancels and we get 1. Other times you cancel 4 minus 4 and you get 0, right? So canceling is not a thing. Here, 12 divided by 3 is what's happening. It's becoming a 4. You're just telling me I did 12 divided by 3 and I got 4. Right? It's the same thing. Different way of writing it. Got people to let in?
No.
Oh, okay. Gotcha. Use the boys' bathroom this time.
I'll be back. Yeah, I'll be back.
This one. What do you want to do first? Times by 3 or divide by 14 first?
Divide.
Why do you want to divide by 14 first? Right, so division, as scary as it is, when it works out, makes the number smaller, which we like, because we like small numbers. 28 times 3, you can do it in your head. It's going to be 90 minus 6, which is 84. No, it's not. It's going to be 90 minus... No, it would be 90 minus 6, 84. 8, 16, 24. Yeah, it would be. Right? Exactly. Or we could say, look, it's 3 times 2 is what's happening here. Way easier, right? 28 divided by 14. 6. Or you do times the top and get, 94 over 14. And if you know that that's 6, then good for you. Right? Actually, it wouldn't be. It would be 80. Why am I struggling with this? It's not 94. It's going to be 3 times this, which is 60. 3 times 4, 84. Why do I keep saying 94? I am tired. 90 minus 12. Nope. I'm a dummy today. There it is. 33. I try to get as much sleep as possible. All right, well, first of all, how about we do 15 divided by 3 first, right? Isn't that what that means?
5.
Okay, so now we have 12 divided by 5 times 5. Well, notice, divide by 5 and times by 5, they undo each other. They cancel. I'm not going to say that. What I am going to say is, what's 5 divided by 5?
5.
1. Times 12 is 12. Do you see how they cancel? Why do they cancel? I don't know. Well, they cancel because 5 divided by 5 is 1. 1 times 12 is 12. Right? Everybody knows, oh yeah, they cancel. They have no idea why. It's because they divide and they get 1. 1 times 12 is 12. Yeah. Of course. Nice catch. Page 8. You want more examples with those or no?
Yeah. One more.
Let's do 37. Page 8, 37. All right, bad news. 24 divided by 9, not going to help us. 15 divided by 4, not going to help us. But here's something cool. How about we do 24 divided by 4? Right? Again, it's all multiplication to division. Doesn't matter which order you do it in. So let's do 24 divided by 4. Well, that means we have 15 times 25 divided by 4, which is what? 6 divided by 9. Right? The divide by 9 came along. 24 divided by 4 was 6. We could reduce that if you wanted. It's up to you.
Oh.
Do you see it now?
Yeah.
24 divided by 4 is 6. Divide by 9 times 15. Okay? We can reduce that first. Let's reduce it. We reduce because it makes it easier on us. Because now we've got this.
Oh, it's 2, not 1.
Right? Now what do you want to do? 15 times 2? Or 15 divided by 3?
15 times 2.
Okay, we get 30 over 3, which is 10. Or you could have done 15 divided by 3 and got 5 times 2, which is 10. Right? Or you could have done 15 times 6. That would have been 90. Divided by 9 is 10. Right? Again, I'm way more interested in how you think about it and if you can do it multiple ways than if you get the right answer. Because sometimes doing it one way is going to be easier than the other, right? Giving you options is important. How you feel? Now, 36. Some fractions don't turn out nicely. Some do, some don't. 7 divided by 13? No, not nice, right? 6 divided by 13? That's going to be a fraction, not nice. 6 times 7 is 42. Now the question is, can we reduce that? And the answer is no, because if 7 divided by 13 doesn't work and 6 divided by 13 doesn't work, then 42 divided by 13 won't. When we say divide by 13, what we mean is there a 13 in there? So for instance, 26 divided by 13 works, right? It's 2. That's because 26 is 2 times 13. There's 2 13s in 26. How many 13s are in 42? Well, you might say, oh, well, there's like a couple of them and then we have left over. No, 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 no. 42 is 2 times what? What? 21. And 21 is 3 times 7. Do 3 and 7 break down anymore? No, so we've got it into the smallest terms, right? Prime factorization is what we call that. Is there a 13 in there when you break it all the way down? No, so there's no 13s in 42. So of course we can't divide it by 13. How many 13s are in 26? Well, there's 2 of them, right? Okay. So that's as simple as it gets. Right. Moving right along. Bum, 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 bum. Solving graph each inequality. Let's look at 38. Be sure to represent your answer as a solution set and be sure that that set makes sense given the problem. So for the problems that I have here, they're just generic algebra problems. We don't know what the context is. There's no word problem to go with it. So as far as we're concerned, x can be any number. It's not like we're counting students and we can't have half a student, right? It's just x is any number. I know. So let's solve this. Now, inequalities are just like equalities, except you have to worry about flipping the sign. So when we divide or multiply by a negative number, the sign flips the other direction. Remember that? No?
Yes.
Okay. So if we divide or multiply by a negative, remember to flip the sign. Otherwise, it's same old, same old. So I'm going to add 14 first. Could I divide by 5 first? Sure, but it'd make fractions. We'd have negative 14 over 5. We'd have 6 over 5, and I'd rather not do that. So let's add 14 first. And we get this, 20. Did I have to change the sign? Did I have to flip the sign? Did I have to flip the sign? No, because I didn't divide or multiply by a negative number. Now I'm going to divide by 5 to get x separated from 5, right? And, whoops, I'm having trouble writing. And I get 4. Should I have flipped the sign?
No.
No, because I didn't divide or multiply by a negative number. I multiplied by divided by a positive number. So x greater than 4. So any number greater than 4 is what that means. So when I graph that, here's my number line. It's only one variable, so I need one axis. Here's 4. X is anything bigger than 4. So does it include 4? No. So open circle. But it's anything bigger than that. So what side is that?
Right.
The right side. So x is somewhere over here. The reason we have to circle 4 is because all of that black coloring right there starts from positive infinity and goes all the way back to just about 4, but doesn't include it. So it's like a boundary line, right? It's saying just all the way, but not including 4. And then it's blank over here from that point onward, right? So blank means it doesn't include, including the blank circle. And colored in means that's where it is, right? So the way we write the solution set is we say that x exists in the real numbers. It's any real number. But it has to be greater than 4. And that's our set notation. So it's a set of numbers, right? Like a collection of things, right? And it's anything greater than 4. Would 3.14 work? No, because it's less than 4. Would 4.5 work? Yes, because it's greater than 4 and it's any real number. So it includes numbers like 4.5. If we said x was integers only that are greater than 4, then 4.5 wouldn't work, right? It would be numbers like 4, 5, 6, 7, 8, 9, 10. 39, I'm going to divide by -3, and I get this.
No.
Why?
Divide by negative.
That's right. You got to flip the sign when you divide by a negative. So now we're here. So let's graph it. Here's -3. That's the boundary, right? Does it include -3?
Yes.
Yes. And then it's greater than that. So it's to the right of it. So x is anywhere greater than -3, including -3, right? It's like saying any number between 1 and 10, you can pick 1 and 10, right? Any number greater than -3, you can pick -3. Now, what if I hadn't flipped it? Well, first of all, it'd be going the other way, right? Second off, if I tested an answer over here in my original equation, my original inequality, it'd be false. So check it out. If I choose a number in here, what's a number greater than -3?
3.
Sure, 3 is, right? So if I plug in 3 here, 3 greater than or equal to -3, does that make sense? Yeah. What if I plug it in here? -3 times 3, which is -9. Is -9 less than 9? It works. Now, if I'd flipped it the other way, this would be where I'd be shading. And I would be saying a number less than -3. What's a number less than -3? -6. If I plug it in here, negative times a negative is a positive, so that's going to be positive 18. Is 18 less than 9? You see, if I don't flip it, it gives me the wrong answer. It shades the wrong side. It's because of that sign change, negative to positive, right? So make sure you remember to flip. Whatever you have here should also be true here. We didn't change the problem. We just made it look different. Number 40. What do you want to do? Times by 2 first, divide by 5 first, or subtract 4 first? Okay. So we're going to get 5 halves x less than 15. What do you want to do? Get rid of the 5 or the 2? Okay, so how do we get rid of the 5 times x? Okay, so what's 5 divided by 5? 1, so we're left with 1/2 x less than 3. If you're just tuning in now from zoning out, here's what we did. 5 halves x is less than 15. We decided, because we have choices, to divide by 5 first. So we did that. 5 divided by 5 is 1, and 15 divided by 5 is 3. We had 5 halves. When we divide by 5, we get 1/2, right? Now what do you want to get rid of? Well, to get rid of the times 1, we'd have to divide by 1, which doesn't change anything, right? So who cares? Let's get rid of the divides by 2. How do we do that? Yeah, so when we times by 2, dividing by 2 and times 2 cancels, right? In other words, 2 times 1 is 2. Divided by 2 is 1, right? So it gets rid of it. And this side becomes 6. Yeah.
What was the solution set for 39?
Oh, 39, solution set was this. X is any real number as far as we're concerned as long as it is greater than or equal to -3. It's basically just this bit, but with telling you what numbers are allowed. Any number is what we're saying, as long as it's greater than -3.
And we can just do XE.
Yeah, you could do this as well. That's assumed to mean any number for x, as long as it's greater than -3, right? The reason I do this is because if they do limit it to integers, you're going to need that exist sign. So getting used to using that is good. X exists in the real numbers, which is every number we're aware of up until next semester. So the solution set for this one is going to be x is any number, as long as it's less than 6. And the graph for this one is going to be, here's 6, that's the boundary, right? And it's any number less than 6, not including it. So x is over here. How you like them apples? I like this stuff because it's actually pretty easy once you get the hang of it. And it makes you look super cool when you write stuff like this, right? Like if I showed that to a calculus student right here, they might understand what that is, right? If they had a good teacher. No, Royer's a good teacher too. I'm not sure if she teaches that stuff or not though. Some people cut it. Usually they rely on people like me teaching algebra to teach them it. And so when they get to calculus, it's good to go. But if they had a bad algebra teacher, or they didn't have one that went into this type of stuff,
I'll go let Thomason.
then they don't worry about it. Okay. I don't know. You want to see more of those or no? Nah, feeling good? We can always come back, right, if we realize we have tons of extra time. Let's look at page 11. Solve and graph each compound inequality. So now, compound inequalities are just we have two at once, right? Before we do them one, now we're doing two. So start with the left side, then do the right side. Why not? What do you want to do first? You want to divide by 12 or add 10 first to get x on its own? What do you want to do, CJ? Divide by 12 or add 10? Okay. That's always a safe thing to do because when you divide, you might get a fraction, right? So let's do that. 12x greater than 72. All right. Troy, what are we going to do now to get x on its own? Yeah, we're on page 11. Divide by 12. 72 divided by 12 is 72 over 12. Can we reduce that? Yep, because 5 times 12 is 60, and 12 more would be 72, so 6.
You want mine tonight?
Yeah,
You do?
I'll take one.
I'm gonna actually had to go do. You know how many of these I have in my car?
Why? Thanks. That's it. Thanks.
Oh, I had to go gas station and get corn nuts. So I left them in my car. I'm stocked up on these.
Good. Now remember, this is still an or statement, right? So we have a number greater than 6, or you can pick a number that fits this, right? What do you want to do first to get x on its own?
Switch it.
Flip them? Why?
Add the 13, subtract the 9, x.
Well, we wouldn't subtract the 9.
Add it.
What do you want to do first?
Wait, get x on
Subtract 5.
Yeah, subtract 5. It's just a number. I think when I put a regular number in front, it confuses you guys. I'm not sure why. If that was 5 minus 9, you know you could add 9 and subtract 5, right?
Yeah.
So why not just subtract 5? Now what am I going to do? And when I divide by a negative, I flip the sign. That too. So we have an option. Our number is either greater than 6 or it's less than or equal to 2. Right, so we have two extremes here. When I graph that, x is either greater than 6 or it's less than 2. Make sure you write them in ascending order, right, from 2 to 6. 2 is on the left, 6 is on the right, because 6 is bigger. Our number is greater than 6, so open circle, doesn't include 6, but it is greater than that potentially, so x is here. Or x could be over here, x less than or equal to 2. So it could be 2, so we color in the circle, because it could be 2. But it could also be anything smaller than 2, so we color this in. So x is here or here. Makes sense, right? Whenever you have a number line with just a dot colored in like that, it means that, look, x is 2. It's right there. There's a dot, like when we put a dot on a coordinate plane, right? So this is saying x is 2, or anything over here, or anything over here, right? Where we color is where x is, okay? The solution set then is this. X can be any number, so it's any real number, as long as x is greater than 6 or x is less than or equal to 2. More importantly than writing, huh?
Like, if this takes, because I have to leave at 3, but, like, my test. And
I mean, I'm doing this till 4, at least. So you can start taking your test now, or you can work on this with us. It's up to you. This is all recorded.
You got 10 minutes.
Baker, are there any in the review guide you specifically want to go over? Right.
Yeah. Wait, what time's the one Monday?
Off the top of my head, is it Monday or Tuesday?
Tuesday.
Tuesday, probably 3 to 6, I would imagine.
Do you have one on Monday for like a different, like geometry?
Yeah,
Would I be able to finish that test in that one? Because I haven't meet-
that's fair. I'd prefer to get that test done as soon as possible, but sure.
because I haven't meet on Tuesday.
Yeah, I understand.
Yeah.
Yeah, yours is from Tuesday 3 to 6. But I'm here from Monday from 3 to 9.
I'm missing my uncle's funeral. Including my review.
Like 9 p.m.
Schoffer, knock it off. Why would you do that?
What?
Why would you do that?
Because my grade defines who I am, not my uncle.
Nice. Wow. Yikes.
My uncle's not gonna get me into college now, so.
Oh boy. All right. You want to see more of those?
Yes.
Okay. Let's look at number 45. Has an and statement. So before we had or, which meant x was in one of two places, right? If we have an and statement, it means it's all together. So let's add 1 and get 6x less than 12, and then divide by 6 and get greater than 2.
Sorry.
It's okay.
I know. pretty much.
Yep, that's fine. Then I'm going to add 10.
I didn't have this.
I'm going to divide by negative 9. When I do so, make sure you flip the sign. So you could write it just like this, x greater than 2 and x less than 10. What I like to do is I say x is between 2 and 10. So here's 2. Here's 10. X is between them. It's greater than 2. It's less than 10. Make sense? It's between 2 and 10.
Wait. Do we need the line?
Yep. So now we graph it. We have 2. We have 10. X is between them both, but doesn't include them. It's like saying pick any number between 2 and 10. Can't be 2, can't be 10. How do you feel about this idea of between? It literally is between it when you write it, right? X is in the middle of 2 and 10. I like it. You want to see another? CJ? You sure? Okay. Because speak up, because they are for when they don't know stuff. I just want to make sure you are too. All right, we got a lot of crazy ones on the backside there, but we'll skip it. We'll go on to page 13. Skylar's deciding whether or not he should become a member of a gym
I am.
to use their basketball courts. The membership cost is $200. Members pay $6 to rent out the basketball courts. Non-members can rent the court also, but they have to pay $15 each time. How many times would he have to rent the courts in order for it to be cheaper to be a member than a non-member, right? He wants to know, should I pay for the membership fee?
No.
Probably not unless he's going to use the courts a certain amount of times. How many times should it be, right? Where the cutoff is, where he's actually saving money, right? So, membership costs $200. So the cost for a member is going to be $200 plus $6 to rent out the basketball court each time. So $6 times the number of rentals, right? So he rents the court once, it's $200 up front, and then $6 for that court. Rents it twice, it's $200 plus $6 twice, so 12, right? The cost for a non-member is going to be $15 every time. So you have to pay more every time you rent the court if you're a non-member, but you don't have to pay $200 up front to get the sweet deal. Now the question is it actually a sweet deal? How many times would you really have to use that court for this is the better deal, where you're spending less money overall? That's what we're asking. So what we're asking is, when does this cost less than that, right? When does the cost for a member actually cost less than a non-member? So the way I'm going to write that is cost of member less than or equal to cost of non-member. Well, cost of member is $200 plus $6 for R. And we want to know when that's less than $15 times R. Make sense? When is cost for a member less than cost for a non-member? We're almost doing a little bit of substitution here. So we've got 6R and 15R. I'm going to subtract the 6R. I'm going to get $200 less than $9 R. And then I'm going to divide by 9. It's going to be not a nice number, but it's okay. It's just saying that R is going to be less than 200 divided by 9, which is approximately what? If that was a 10, it'd be 20, right? So if you rent the court less than more than 20 times, then this is a better deal. But if you're planning on renting the court less than 20 times throughout the year, probably not a good deal, right? So we're going to say that R can't be any number. What does R stand for? What is R? The rent is $6. R is the what? What does R stand for?
You go up a little.
Yeah. Yeah, the time that we rent the court. Every time we rent the court. So the number of court rentals. Now, can you rent the court 1.5 times? No. So there is a restriction on R other than it just has to be less than 200 divided by 9, right? It also has to be what kind of a number?
Real.
Well, all numbers are real as far as we're concerned in here. A rational number? Well, a rational number could be 1.5, right?
Integer.
A natural number? Natural numbers include all the regular counting numbers, but they don't include 0. Could R be 0? Yeah, it could. So what we really want is the whole numbers. And the whole numbers are n sub 0. Any natural number starting at 0. You weren't here for this at the beginning of the year, and you missed the review at the beginning of class. So we'll go back and look over that towards the end, okay? So R is any natural number, but it also has to be greater than 200 divided by 9. That's the solution set. If we had to graph that, we put 209 in the middle. We do an open circle, then we color to the right. What?
It doesn't say graph or
Nope, it doesn't, but if we had to, we'd do that. There's the solution set.
you want us to do the solution set.
Yes. On the final, it will say to do that. Here, the directions don't include it, but you could if you had to, right? 53. You want to look at it or no?
Sure.
Isaiah has $600 in saving account at the beginning of the summer. He wants to have at least $250 at the end of the summer. He withdraws $35 per week for food, clothing, and movie tickets. How many weeks can he withdraw money from his account? We have $600 in savings. And we're withdrawing $250. Right?
Minus 250.
Oh, no. Sorry, we're not withdrawing $250. We're withdrawing $35 every week. So $35 times the number of weeks, right? And he wants to have at least $250. So the amount I have in savings after withdrawing, right, should be greater than or equal to $250. Does that make sense? I start with 600. I'm subtracting 35 every week. And when I'm all done, I want that to be greater than or equal to 250. This question is, how many withdrawals can you do, right? How many W's? So how do you solve a problem, Maria?
35W by itself.
Yep. So we need to get this by itself, so we're going to subtract 600, which is going to leave us with negative $35 W, greater than or equal to 250 minus 600. That's going to be negative 350. Big minus signs there. Well, if you want, we can negate both to get rid of the negative signs, right? So we're here.
And yeah. Right.
Yes, we do. So when I negate both, what did I really do? I divided by a negative number. I divided by -1, right? So that means I have to flip it. Good catch, Isaiah. And then I divide by 35. You could have done that all in one step, but, you know. We get 10. Should it be $10? No, it shouldn't. Because W isn't dollars, is it? It's weeks. So this is gone. And the reason I know that has to be gone is because when I divided by $35, I divided by $35. Dollars and dollars divides and goes away. 35 and 350 and 35 divides and we get 10. 10 weeks. That's what that is. The dollar signs divide out just like a number would. $35. I'm sorry, $350 divided by $35 cancels dollars, right? They divide out. And we're left with whatever's left over, which is weeks. W was weeks the whole time. Okay? So W has to be less than or equal to 10 weeks, so we'd write the solution set like this. Can W be any number?
No.
Not any number less than 10, right? It also has to have other thing. What? Has to be what? What kind of number does W have to be?
A real number.
Yep, sorry. Not a real number.
Whole number.
Whole number, right? 0, 1, 2, 3, 4, 5. And the whole numbers are the natural numbers starting at 0. So big N sub 0. How do you feel? No? How do you feel about this, Isaiah? Great. This, not so much. So it's just this. Plus, W has to be a natural number. And you know what the natural numbers are, right? 1, 2, 3, 4, 5, 6, 7. Well, this is the whole numbers because it's big N sub 0, starting at 0. If you need to know what the symbols are, look at your first page. I gave them to you. Natural number is N sub 1, so natural number starting at 1. 1, 2, 3, 4, 5, 6, 7. Whole numbers are natural numbers starting at 0. 0, 1, 2, 3, 4, 5, 6, 7. Integers is set Z. It's kind of weird, but it is. And that's just all the natural numbers and their negatives. So 1, negative 1. 2, negative 2. So it's all these guys plus their negatives, right? And then the rationals are where fractions come in. Okay? So a rational number is any number including fractions. But we'll be more specific about that later, okay? If you want to look at the first page, you can. Later? Okay. 14. You want to do page 14's question or no? It's more of the same of what we've been doing. We can if you want. Page 50, number 54, page 14.
How long do you think this problem will take?
The rest of the time. Well, actually, we already passed. I'd say at least 5 minutes. Why?
It's 3:03.
Yeah, just go. It's okay. I've got it recorded. You can watch it. We're also doing another review on Tuesday. Tuesday.
I'll just turn this back in right here.
Works for me. You get it done whenever you can. You come in early in the morning, too. I prefer you not to because I'm going to be exhausted on Monday. But
We won't be able to come to this game.
okay.
Alright. So, wrote down the original ones, and then the primes, and then I applied this vector to the original ones. And
Okay.
I moved it up, but I know it's gonna have to. I feel like once I get the roll down and it expands, it's gonna turn into that. That's one. I don't know.
All right. So what are you doing here? So the first thing you did was slide it, or did
Yeah.
you put the center of dilation on you? What are you doing first? Are you getting it the right
vector
size?
from you to the origin.
Okay, gotcha. So you're moving everything to there.
Mm-hmm.
So now your rectangle is here. Okay.
Right there.
Well, if you moved you to the origin, U's on here, which means our rectangle's here.
My vector I got was 2, 4.
You mean 4, 2?
Oh, I went up and across.
Well, 2, 4 would be 2, 4, and that would put you there. That's fine. Is that what you wanted to do? Move you to there?
Yeah, sure.
Okay, so now you're there. Now what do you want to do? Get it the right size?
Yeah.
Okay, so we need to multiply this by, looks like a 5, right?
Yeah.
Multiply that by 4.
Yeah, but I like when I tried to do that with like, here's the one I'm supposed to, like, here's what I have right there. That's what I got.
Mm-hmm.
It doesn't match up.
Right, so you're going to get the right size after you do 5 and 4,
Mm-hmm.
but it's going to be in the wrong spot.
All right.
Now you need to slide it into place.
All right. Oh.
Last thing, see how V and U are on the left and the right?
Yeah.
And this is on the right and the left.
So I'm trying to flip.
So you need to flip it somehow. So what I would do before or after growing it, I would flip it and then I'd slide it into place. You're going to end up in like really far off location, right? But you know how to do it. Make sure you write the full rule out when you're done, right? What you did.
Yep.
All right. Are we doing page 14, number 54 or no?
I don't care.
Are we doing 54? No? Come back? All right. 55. Doing that one. Similar to 54? Nope. Okay. 56. Similar to 54. We'll skip it. Sorry, Troy. 57. 1/2 a number increased by 3 is greater than 0 or less than or equal to -3. Now that's a sentence. So 1/2 of a number. So half of n, or x, or whatever variable you want to use, increased by 3. So we're going to add 3. Is greater than 0. Or all of that is less than or equal to -3. If you take it slowly and break it down, it's not so bad. What's tricky here is that it uses or, and you have to realize that it's two separate things, right? It's everything they said before is greater than 0, or everything they said before is less than or equal to -3. Try to see if you can make sense of that. Again, writing this down and copying what I have without understanding what it means nothing, because you have to do this on the final, right? So if you don't know what it means, ask now. Huh?
What were you asking?
Well, what?
I know. I'm sorry.
It's all right. Half of a number increased by 3 is greater than 0, or half of a number increased by 3 is less than or equal to -3. Want to do 58?
Oh, we just have to.
Yeah. That's it. No solving. 9 less than a number is no more than. Yeah, I know. 8 and. 9 less than a number is no more than. So this can't be any bigger than the other. So it needs to be less than or equal to 8 and.
Question. Could we put the 9 with the n?
Like 9 minus n?
N, since it says 9.
You could do -9 plus n. That'd be the same thing. 9 minus n would be 9 minus a number. So take 9 and subtract n is different than take a number and subtract 9, right? And is no less than 3. So this same thing is no less than 3. So it can't be smaller than 3. So it needs to be bigger than 3, right? No less than 3. How many bagels do you need? No less than 3. So if you give me 2, nope, not going to work. Give me 3, okay, that fit my stipulation, right? So it could equal 3. Word salad sentences continue. The sum of 4 times a number and 8 is equal to 0 and 12. The sum of 4 times a number and 8. So that's what we have to write. The sum, so that comes first, of 4 times a number and 8 is between, meaning it's greater than one side, less than the other, right? It's between 0 and 12. That thing is between 0 and 12. Are we feeling okay about this? Because this is hard stuff. The sum comes first, so n plus 8, right? Of 4 times that is between 0 and 12. The sum of 3 consecutive odd numbers is between 26 and 34. So first off, something is between 26 and 34, right? That's what we're saying. That something is the sum of 3 consecutive odd numbers. So start with the number, n. How do I find the next odd number after n? So if n is 23,
N plus 2.
then it would be 25 would be the next number, right? So I do n plus 2 next, plus n plus 3, or n plus 4. So n is the starting number. N plus 2 is the starting number plus 2, meaning it's too late. It's the next odd number up, right? And then it's the odd number here, n plus 4. This is hard stuff. Does this make sense? Our starting number plus the next odd number plus the next odd number. Because if you start at an odd number like 23, and if you add 2 to it, you get 25. You add 4 to it, you get 27.
This last year, I believe.
Good. That's sick.
Except we put like parentheses between
Each of these?
N plus 2.
To show that it was an idea.
Yeah.
Awesome. Who was your math teacher last year?
Wayne. It's Miss Wayne.
Good? You speak no evil. I like that. For this one, we said consecutive odd numbers. So can n be any number to start? No, it has to be an odd number and it has to be a whole number. So n exists in the natural numbers and is odd because you have to start at an odd number. And we know that it's between these. All the rest, it didn't really matter. So I didn't bother writing it. Yeah. And is natural and it's odd, right? A natural odd number. And it's going to be between 26 and 34. Learning how to write restrictions is important. Very, very important. Especially for next semester. We're going to be doing some drawings in Desmos.
I'm not even gonna be in here.
You guys.
That's sad.
might as well like switch
So normally, if you have a line, it goes on forever, right?
straight.
And this line would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's y equals 9 because we have 0, 9, 1, 9, 2, 9, 3, 9, 4, 9, 5, 9, right? It's where y is always 9. But what if I wanted to make a drawing with this? Well, I don't want my lines going on forever. Maybe I wanted to make a box. And I wanted the box to be from here to here. Well, that's between 0 and 1, 2, 3, 4, 5. So I need x between 0 and 5. And if I tell Desmos that, it'll cut off anything that doesn't fit that. And then I can do another line down here, maybe like y equals 1, 2, 3, 4, 5, where x is between 0 and 5 as well, right? Between 0 and 5 here. And then I can do another line here where y equals, or x equals 0 and x equals 1, 2, 3, 4, 5, right? Where y is between 5 and 9. And it makes me a box, right? So if you don't get that now, it's okay. We haven't learned that yet, but that's why restrictions are important, right? Some really cool things with them. So an odd number, that's any natural number that's odd, goes there. I wonder if you could just write any number that's odd, because I don't think like 1.3 is an odd number by definition. Huh?
You do that for both.
No. Those are all just all real numbers, right? So you could, but yeah. 61. We're getting into familiar territory. What is slope?
Rise over rise.
That's right. Do you guys want to do these or no?
Yeah.
Yeah? Okay. M equals the rise over the run. Schlaffer, how do you feel?
Great.
Yeah?
Yeah, I think I got a B.
Sick, man. At the end of the final, or maybe next year, because we have a semester 2, right? and we have to do a portfolio or something at the end. It's like, well, you're not going to tell your math story again. I'm thinking the narrative should be, what are you going to tell kids next year when they take my class as advice?
It is interesting.
Be prepared.
Can't BS your way through it, can you?
Warning.
You have to know your crap.
Caution.
Yeah. You have to know your crap. Rise of a run.
Change in Y and change in
I love how you said change and not triangle. Very good. The change in Y, right? That's what delta means. That triangle means delta. Delta means change.
I wonder how the grown-ups feel that had Miss Bechtel for their high school career, and then they have their kids that have you, and they're like, "What's happened?" They're like, you know what I mean?
Oh, the difference between me and Bechtel?
I mean, besides, like 4 years younger, but yeah.
Right, we have very different styles. Although the way we think about math is very similar.
Y2, Y1.
Yep, so the change in Y. Now when we change, we're talking about subtraction, right? If I'm on 2 and I went to 10, how much did I change? Well, 8, right? Subtraction. Subtraction is change, subtraction is distance. Thank you.
No, I'm good.
So we have vertical distance. We have horizontal distance. Is that what you're missing? Oh, I thought you were saying you were missing this on your test.
Oh, no.
Good.
I was. Wait.
Mm-hmm.
I only got nice. Well, 3 of the 4.
Yep. Well, 3 expressions, and the explain them is this. That's what slope means. Instead of using slope formula, I like to just think of the change, right? So if I'm on 3 and I went to 5, well, I went up 2, right? Makes it a lot easier than plugging in 3 and 5 here and then doing math, right? People know what it means. You don't have to do that stupid formula. Which means you're not going to miss like a double negative or anything crazy.
What we should do?
That's what I would do.
Because you should have a meeting with the junior high math teachers so you're on the same page. So then when they get here,
Yeah.
Actually know something.
We try to do stuff like that. I mean, I'm a newbie, so I wasn't there for the last meeting. Yeah. There's a huge difference between a junior high and a high school as well. Not so much between freshman and junior high, but between sophomore and above and junior high is a huge difference. Something happens magically sophomore year.
Difference between us and them.
Sophomore year, magic happens. Right now, you guys are mostly advanced middle schoolers.
you know what we should do tomorrow?
But you're getting better.
If we have a decent crowd for geometry,
I would imagine we will.
we should go swimming.
Swimming? Great idea.
Who's gonna stop us?
That's right.
We need a certified
We should do a math lock-in next semester for the final.
Oh, no.
Thanks.
That would be fun. Swim party. Do some math review. Swim. Cook out.
There's a joke to be made there.
Slope-intercept form of a linear equation and identify each part. Slope-intercept form. What form is that?
Y and Y.
It's the one with the slope and the intercept, right? Come on, I need you to think. Tired of you guys getting this one wrong. It's easy.
Y minus.
No, that's not it. That's a different
Is
one.
that the number 2
Mm-hmm.
test?
No.
Oh, the test is
Oh, I thought-
that's all. That's weird.
I thought it was like
Right?
maybe
It's the slope-intercept form. It's the one with the slope and the intercept.
I was gonna do that for teaching the one topic on my
Good.
portfolio, but I couldn't find anything.
Teach what it means. Teach how to use it. But again, what it means is way more important than how. Okay? But I need both.
It means that it has the slope and the point. Or, yeah, intercept.
Whoops, these are our variables, right?
Well,
Don't even label them. Don't even label them. I feel like there's not a good way to label them. There are variables, right? They contain every possible coordinate that's going to be on that line, right? 63. Point slope form. That's the one with the point coordinate, right? And the slope. So that's going to be this.
Y
All right, I'll see you tomorrow, Mr. Matt.
Hey,
You have a good day.
later, man. You all right?
Yeah, I'm going to Alex's house.
All right, cool. Who?
Anderson.
Anderson?
Alex.
Lives right up the road.
What's going on with Anderson?
We're gonna hang out.
Oh, I didn't know you were buds. Say hi.
Well, we're not really buds. It's just like,
Ooh, sorry, Alex.
no, that way, I don't know. We're trying to make the most of my time here.
Yeah, that's rad, man. Later.
Good night.
Hey, you too.
See you tomorrow. I'll bring my swim trunks.
Do it.
X minus K.
It's H. I said H.
Let's do.
K. It's K and H.
H.
Ah! The other one's K, man.
Yeah.
Oh, whoops. Did I point to X for the slope? Schlaffer, you're in my head. Slope is M. And then the point is H and K. Notice the signs are different. Okay, notice the signs are different. In the formula, they're negative, meaning that they're the opposite sign, right, of whatever your point is. Does that make sense?
No.
So if I was saying that a point on this line was -2, 3, well, then I'd have +2 up here and -3 there, right? It means change the sign, right? That's what these mean. So it's the opposite sign of whatever you have down here. So 2, 3 would be -2, -3, or -2 up here and -3 there.
Could you write that like K, comma H?
Hmm.
Okay.
Two basketball games.
I had a,
Decided that the ball, so
I had a practice today, so
Let's try a basketball game.
basketball.
Find the slope between 2 points. All right, so we could use slope formula, y2 minus y1 over x2 minus x1. And that's what we are going to use, but we're going to do it in our head. And we're not going to do it via subtraction. We're going to do it by thinking logically, right? The change in y over the change in x. So how much do we change? Well, look at the x values. Here are our x values, right? I'm sorry, y values, right? So pick which one to start at. I'm going to start on the right. I just always do that. You could start on the left. Just be consistent.
Wouldn't that
So we're going from -2 to -1.
one?
We added 1, so that's our rise, right? Because that's our change in y. If you had plugged that in, -2 minus -1 in the slope formula, you would have gotten -1, right? And then on here would be a negative number to cancel it, right? You would have gotten -1, but then you would have got a negative number down here too, and they'd cancel and make positive. Yeah.
This way's easier.
0 going to -2. Again, if you know what it means, there's easier ways to do it, right? 0 going to -2. How much did I change by?
-2. So the slope is -1 over
-half. That's the slope. Then write the point slope form of each line, and then the the slope intercept form. So point slope form,
I hate the point slope form.
yeah, I know, is going to be y minus h plus k, or I'm sorry, not plus k, equals m times the quantity of x minus k.
You
H. I'm such a dummy. Whew, man, it's going to be a long one. All right, first review session. I'll be able to get a lot of sleep tonight, though, so that's good. So anyway, h and k go here and here. And then our slope. So we just found our slope, right? Our slope is -1/2. And then we pick a point, because any point on this line could go there and it would make the proper equation. Isn't that kind of rad? Any point in the line you plug in and it'll make the same equation. So which point do you want to use, the first one or the second one?
don't even know how to do this part.
Well, h and k is a point.
I don't know what K and H reference to.
They reference to any point on the line.
So like the
but we don't have the.
These are points on our line, aren't they? Right? Right?
so how would you get those for
What? So I'm going to choose the first coordinate because that's on our line. Either of these would work. Any point on our line would work. And that becomes a +2 and a +1. Because it's the opposite sign of whatever they are, right? That's what that negative in the formula means.
so the H and K are the same one. Like that's one and you can do that as
Yeah, you could do another one. So you could write that, or, so this is an answer, or you could write y minus 0 equals -1/2 times the quantity of x. Why am I such a dummy? Y minus plus 2, x minus 0. God. Do you know why it's that and not the way I wrote it?
Because the y is negative.
Yeah, y part is negative 2, so it's a positive 2 down here. It's 0 here, so it's minus 0. Could you just write x? Sure. Yeah, you could.
That's where I'm confused.
It's just useful because if somebody says, to you, hey, I know I need to make a drawing where my line goes through this point, it hits that, right? And I want it at a certain angle. Maybe I want it like a slope of a half. Then you know that the slope needs to be a half, and you know one of the points you go through is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you need to go through 5, 5, right? How do you plug that into decimals to make it do that? To hit it at the right angle and go through that point? Well, we use point slope form. And type that in, you're good. Right? That's the beauty of point slope form. It's really useful in that regard. I want it to go through that point and at this angle, right? There it is.
So, those switch to additions.
They change the signs, yeah. So notice in the formula, it says take your y and subtract whatever your k is. Take your x and subtract whatever your h is. So if h and k are positive, then they're going to be negative up here, right? If that's 3 and 2, you're going to subtract 3 and subtract 2. If it's negative 3 and negative 2, you're going to add 3 and add 2, right? You're subtracting a negative.
And then once you have the numbers, you have to have it like in a specific order, like H and K.
Yeah. H is the one that goes with the x, so x, right? And this is the y part, so it's going to go with the y over here. Cool. Good question. Lastly, we need to get this into slope-intercept form. That's the y equals mx plus b, right? So the way we do that is we're going to distribute that half and then subtract the 2. Now for the bottom one, since this goes away, distributing that half is super easy, right? So I could take it and do this, right? And then I just subtract 2 and I get this. You'd get the exact same slope-intercept form if you'd done the top equation. How do you feel? Oh, I goofed this one up, didn't I?
Plus 1, like,
Didn't I plug in the wrong spot?
no,
Minus 2 goes here,
no,
plus 1 goes there.
that's y.
Yep.
Minus 1 is y.
Y minus 1, yep, so goes here.
Yeah.
My bad. Exhausted. The reason I knew that is because I started distributing this in my head, and I was like, that wouldn't get you the same equation as this. Because we're talking about two different lines. That's not what we want with the same line, right? Want to try another one?
Sure. Wait. Let's do 67. Why? 'Cause
Lots of negatives. And both y's are negative 5.
what happened? Oh, wait.
I just picked out a random.
What?
For how you did the point slope form. No, not that one. Slope intercept form.
Yeah, this one.
You did it for the bottom one, not the top one.
You do it for either. If you had done it for the top one, it would have gotten the same thing. So check it out. If I take a piece of paper, cover this up. So notice we're here. I'll write that nice and neat so you can see it because I made that mistake. Now imagine I distributed here, right, and try to get point slope form. Well, I get this, right, because half of 2 is 1 negated. And then I add 1 and I get this. I'm sorry, subtract 1. My bad.
Yeah, that's 2. Subtract 2. That's subtract 2.
Well, I subtracted 1 to get minus 2.
You did it. You said subtract 2.
I'm an idiot. But see how it turns out the same? So any point you plug in for here and here will get you the same line.
So it's just negative.
Guaranteed. Yeah. No matter which equation you go with, it'll end up being the same point slope or the slope intercept form. Because there's only one slope intercept form of a line, right? And it's that. There are lots of point slope forms, right? Because as soon as you make a line, you have lots of points to choose from. Want to do another one?
Yes.
Okay. Let's do 67. Actually, let's do 66 and then do 67.
Oh.
So 66 is this. So I'm going to zoom out, because I feel like I'm constantly having to drag the paper around, and then I'm going to do this nice and big. I got new Expos, or not Expos, new Sharpies from my Secret Santa. Because the school does a Secret Santa thing with the teachers.
What did you get the teacher that you
I
have?
can't tell you, because then you'd be able to figure out who I was Secret Santa for, and that is still a mystery yet to be solved.
Oh, you haven't done it yet.
Maybe.
Okay.
So, slope intercept, point slope form is this. Y. Let's find the slope first. God. Okay, so finding the slope.
Negative, wait, that's not, never mind.
This is number 66. I'm going from -5 to 1. What did I go by?
6.
Went up by 6. And then from 7 to 4, I went down by 3, right? So there's my slope. I can simplify that, so I will, because it makes it easier for me to work with it. That's -2, right? 6 divided by -3. So our equation is going to be y minus whatever the y value is that we chose equals our slope times the quantity of x minus whatever our x value is we chose. So which coordinate do you want to use? The first one or the second one? The first one? Okay, so I'm going to use this guy. 4 for the x, 1 for the y. Didn't make a mistake that time. Didn't make a mistake. So I'm done with that. Now I need slope-intercept form, right? So what do I do? Define slope-intercept.
Move the -1 over.
I got to do that and distribute the -2, right? So when I do that, I'm going to get y minus 1 equals -2x plus 8. And then when I add 1, I'm going to get -2x plus 9. So the y-intercept is at 9, and the slope is at -2. Yay, slope-intercept form. You tell us extra stuff. Slope-intercept tells us a specific point, the intercept, whereas slope-intercept form, or slope-point form, is just general point that's on the line. Could be any point. Do one more. Nine hours of this tomorrow. What?
Why are you doing 7 after that?
Ready to do 67? 67, its coordinates are -4, -5, and -3, -5. So if they say, hey, I want a line that goes through both those points, and you need to type that in Desmos, you could use these formulas to figure out what that line would be. So let's find the slope. Going from -5 to -5, how much did I change?
0.
0, right?
Oh,
So we have 0
1.
-1.
over, true. In the end, it won't really matter, but yeah. -3 going to -4 is -1.
Sorry.
That's a slope of 0. So think about what that means.
This is a straight line.
All lines are straight. But it's going to be a perfectly what line? Horizontal or vertical? Horizontal. Because 0 slope, no steepness, right? Infinite steepness, vertical. So there's our formula. Which coordinate you want to use, first or second? Second one. Ooh, we're changing it up. So we're going to do -5, so minus a -5, which means +5, and minus a -3, which is +3. So there it is. Now you'll notice that when we get slope-intercept form, we're going to distribute that 0, right? What's that all going to become?
0.
0, right? Goes away.
That's the
So in other words,
point slope form.
-5.
negative.
Yeah, it's point slope form. It's kind of silly, but because it's times 0. But it tells the story of what's going on here, right? Slope is 0, and it goes through -3, -5. So this would be that, and then we subtract 5. So that's slope-intercept form.
It's kind of crazy.
It is. And now the line y equals negative 5 goes through here. So where's the intercept? Negative 5.
Is that actually negative 5?
No, it's negative s.
He was talking, did I actually hit the right spot? But I did. I did. Rad, man. Rad. How you feel? If 0 is on the bottom, that means infinite slope, which means steepness, because we divide by 0, right? It's going to break math. So it's undefined. So infinite slope, which means we have a vertical line.
65.
And when that happens, you can't even write the 0 there, because remember, it's not 0. It breaks math. If it was flipped, it'd be craziness, right? So you just say no form, or you could write it like 1 over 0, I guess, there, and I'd understand that you meant it was undefined. And then when you get to here, you wouldn't have y equals anything. You'd have x equals something, actually.
That'd be if I did 65.
Yeah, let's do 65. 65 is 6 comma 9. And 6 comma 7. And right away, if you start thinking about what stuff means, you should see those 2 points and realize, oh, look, no horizontal change, right? So if it's no horizontal change, what kind of a line is it going to be? Vertical, right? Exactly. So we're going to do the work, but it's going to be silly. We added 2, right? And then we did nothing, which means that this line is undefined, right? The slope is undefined. Undefined. So for point slope form, you could write something like this. Y minus 9 equals 2 over 0 times the quantity of x minus 6. You could do that. I'd accept that. It's going to break your calculator or Desmos if you do it, but yeah, you could do that. And now we're not even multiplying by 0 here, but you want to see something fun? How about we times by 0 to both sides? Well, in theory, if this works, should get rid of the 0 here, and timesing by 0 gets us 0 over here, right? Divide by 2 to everything, right? We get negative 3. And then x equals 3 is the line. That's what it says. Is that it? We want a line that goes through 6, 9, and 6, 7. Well, here's 6, 9, and here's 6, 7. X equal 3? No. Right? So you see how this breaks math? Doesn't work. Why didn't I do it right?
Because you have to multiply the negative 6 by 2.
Oh, that's right. Thank you. 6. There we go. Oh, man. You can confirm. I teach 7th hour algebra 5 days a week, and I don't make nearly as many mistakes. In fact, I rarely make a mistake. But recently, out of exhaustion. So there we go. X equals 6, which is in line. I think I proved thoroughly that I have nothing memorized, but I understand things a lot, and I follow the logic. But when my logic is wrong, I'm screwed. All right, so there's the line. That's what it'll look like. Thank you. So what's our y-intercept? None, right? There's no way to write the slope-intercept form because there's no y-intercept. It never hits the y-axis. Better? Okay. Well, what? What? Please.
What happened?
Just you and your hair.
Yes. I am very, very sleepy. I guess I'll keep these. All right. Wall. My beautiful mistake. All right. Yeah, this one's empty.
Why don't you fill it?
Because I don't have time for that, and I don't ever use tape, so why would I? Nice.
You have to use those 2 points.
Mm-mm. You can use any two, but the reason I highlighted those is because sometimes it's hard to tell if it really does go through that point or not, right? So, find the slope. Could you write down those 2 coordinates?
Yeah.
Could you then do the thing we did on the last page and find the slope? Okay, let's move on. Good.
Uh,
Or even better, if it's on a graph, look what we're doing. Pick a starting spot. I pick that one to start at.
Down
I go down 1 and over 3, don't I? Whoops. Math is hard when you're tired. Yay. If I was any other teacher, you'd have like a bunch of those questions on your exams. Because that's what normal teachers do. They give you really simple, small questions like that that are worth a lot of points to boost your grade. And I'm just like, that's too easy to even put on there.
That's all my old math teachers.
Right? Like, what's the point? How about I save you time and assume you get it right by giving you bonus points? Right? And if you don't get it right, then you won't get this right. So I'll get you there, right? So, fair enough. 69. Nice. 72. Find the slope of the line given the 2 points of the line, then graph the line. Is the slope vertical, horizontal, positive, or negative? Well, first of all, looking at this, am I going to have a horizontal or vertical slope here? You think maybe because the numbers are the same, but look at it. 5 and 2, there's change. 2 and -5, there's change. So is it going to be vertical or horizontal? No. It's going to be at some angle, right? Let's figure out what that angle is, what the slope is. Looks to me like 5 going to 2 is we subtracted 3. And 2 going to -5 means we subtracted 7. Because they're super easy. Troy, could you write those 2 coordinates down and find the slope?
No.
Could you also just eyeball it and say it's down 1 over 3? Or left 3 up 1? Yep. I know. Because they're good practice. I think looking at this, you might be confused because it's a different format, right? It's a different way of asking the question. But once I ask the question and tell you what the question is, you go, oh, easy, right? But it's important to show you guys that, hey, there's another way to ask it, right? So that's 3 over 7 for a slope reduced, right? Before we graph it, is it vertical slope? No. Is it horizontal slope? No. Is it positive slope? Yes. Which means we're going up and to the right because 3 to the right and 7 up. Then it says graph the line. Super easy to do. 1, 2, 3, 4, 5, up 2, 2, up 5. 1, 2, 3, 4, 5. Because it's the points they gave us, right? Done. Done. If you really wanted to, you could get that in slope-intercept form and do all the stuff we did here, right? And then graph it. But why? But why, I ask you? How would they know the difference? Whether you did that or you just graphed it based off the points. Well, they'd be able to see that you put the points down and drew a line. But if it was a computer, they couldn't tell. And it gets the job done, so who cares, right? You want to see more of those or no? Yes? Which number? 73? Yeah, just put the points down, draw the line, right?
-5, 2.
Why don't we just? Oh, we actually have to find something.
That's a nice.
Yeah, you do have to find the slope, right? It says so, right? Will I be putting those on the exam? Probably not. Are you going to see this more likely that gets the same thing done and then I say graph it? Oh, yeah. Oh, yeah. Right? Because that gets everything taken care of. All in one problem. I'd rather do that.
All your problems.
Yes.
I like your line.
Thank you. It missed. Let's skip more of these. 75. Solve each linear system by graphing. Guys, we're almost done. It's almost 4 o'clock, and we're starting to get the stuff that was on the last test.
This was on this slide.
This was a lot of pages, but do you feel overwhelmed for this final?
Yes.
Really? I hope not so much. I mean, you a little bit because there's stuff in the beginning that you're like, I don't know about yet, but you'll feel fine. Okay? But so far, the rest of that, was that like,
The stuff that you did.
nope, nope, nope. How about, so do you feel overwhelmed by all the other stuff we've done, though? Like recent stuff? No,
I
right?
remember it.
Yeah, because you actually learned it the first time. Most of you.
I was playing football
That's right.
at the time. Hey, but now I know it.
Yes. But think how great your grade would be if you had paid attention the first time. It'd be a grade that's probably more accurate to how much you understand. Well, how much you understand now, right? How much you understood earlier? No, that's accurate. All right, so here we are. Solving by graphing. So we're going to graph them both, see where they intersect, right? Where they intersect is where they agree. And that's the solution for both of them. We need a number that is another number plus 3. And that same number is also that same number negated in minus 7. Okay? It's a weird way of thinking of it, but that's the idea. We're looking for two numbers that work like that. A number when we add 3 to it, you get the other. And another number when you negate it and subtract 7, you get the other, right? There's only two numbers that work. And it's where those two lines intersect. Or maybe it's impossible to find a number like that. Then we have equations that never intersect. They're parallel, right? Or maybe any two numbers would work, right? Maybe not any two numbers, but lots of possible two numbers would work. It's where they both are the same line, right? Not any two numbers, right? You couldn't do 1,000,000 and 0. That wouldn't work. But maybe there's a lot of possible solutions, so they're the same line. Okay? So let's graph them both. What form are these in? Isaiah, what form are these in?
Oh, what's it called?
It's the one with the...
Point slope. No.
Point. No,
Point
slope
slope.
intercept.
Yeah, it's the one with the slope and the intercept. Come on, guys. It's okay. No one knows the names. They're so easy if you just think about it, but no one wants to think about it. So the bottom one I'm doing in purple looks like our y-intercept is -7. Now, what is a y-intercept?
Wait, do we have to like do this a different way, or can we like put the negative x minus 7 in for y?
That's substitution. I said solve by graphing. Well, it's good to know what these solutions look like and what they mean. That's why I make you do it this way.
Okay.
Sometimes it is easier to solve by graphing. In fact, inequalities you have to solve by graphing. So what is a y-intercept? Because it looks like our y-intercept is -7. What is a y-intercept? What's a y-intercept?
Y gets intercepted.
It's where our y-axis gets intercepted. So it's going to be intercepted at -7. So we go to the y-axis, and we go to -7. 1, 2, 3, 4, 5, 6, 7. And we know the purple line is going to cross right there. Bless you. So if we know the line crosses right there, we know that's a free point on our line, right? That's a point on our line. So if that's a point on our line, we should be able to use our slope and find another, right? So let's do that. Let's go down 1/1 from a point we know that's on our line, and we'll find another point. We could keep doing that and find another, and another, and another, and another, and another one, and another one, and another one. That's why a slope-intercept form is so useful, because it gives you a free point, the intercept, right? And because it gives you the slope, you can use it to find all your other points, which means you get to make a line, right? That's why point-slope form works, because it gives you a point, and you can use your slope to make the rest of the line. So there's the purple line. Again, the more carefully you draw it, the more accurate your intersection will be. My line was drawn very poorly. The top one's the red line. What's our y-intercept here? Because it's in slope-intercept form. What's the y-intercept?
3.
Yeah, so we go to 3 on the y-axis, because that's where it crosses the y-axis. And that gives us a free point. And then if we go up 1/1, we should be able to find all of our other points. And again, the more accurate you make this, the more accurate your intersection will be. My lines look like they should intersect right there. If I'm going to give you a graphing problem, it's going to be a nice intersection, because otherwise, what's the point of graphing it, right? So the point of intersection appears to be -1, 2, 3, 4, 5, -2. So the two numbers that fit both criteria is -5, -2. So that's our answer. How do you feel about that?
Very good.
So for inequalities, we have to color in different areas, right? Because that contains all the possible answers in that area, right? For equal signs, it's saying all the possible answers are on this line. So we only color the line, right? And where they intersect is that one point where they agree. So that's the one solution that works for both, right? How do you feel about that concept? I never understood what lines meant growing up in math. It was just you draw them, they're a thing, right? But that's all the possible answers for the purple, right? For instance, -1, -6 would be a possible answer for this, right? You plug in -1, you get -6, right? Et cetera, et cetera. All the possible answers for the red, like, I don't know, 2, 1, 2, 3, 4, 5 would work. If you plug in 2, you get 5, right? All the possible combinations are here. All the possible combinations are there. Where they agree is where the possible combination for both of them. Right there. Just one. where they both have the same answer. -5, -2. 76. What form are those in? It's not point slope. It's not slope intercept. What form is it?
It's called the.
Mitchell always gets this one in class.
Of course he does. Fuck is the only one he knows.
Standard.
Standard form, very good. And they call it standard form because we have a bunch of x's and y's, and then we have a number off on its own, right? I don't know. It's kind of silly. It's the form we use probably the least. However, it's really useful because it's really easy to find x and y intercepts with this. So while this one doesn't give us the slope, it does give us 2 points for free, essentially. And you need 2 points to make a line, right? So if I look at the top one, let's have that be the purple equation this time. Remember, x and y intercepts have 0 for x and 1, 0 for y. So right here, something comma 0 would be an x-intercept, right? Right? Think about it. Anytime we hit the x-axis, the coordinate will be like 1, 0, or 5, 0, or -6, 0, right? It's always going to have a 0 for a y, right? So our x-intercept is going to be this. So if we plug in 0 for y, that gets this gone.
-6.
And we get x must be -6. So -6 comma 0 is where it hits the x-axis, right? Now, how many points do we need to make a line? We need 2, right? At minimum. So let's find another easy point. Let's find our y-intercept. Well, anything on the y-axis is going to be 0, 1, 0, 2, 0, -5, right? It's going to have 0 for x. So if we plug in 0 for x, we get 3y equals -12. So it's going to be -4. And again, with 2 lines, or 2 points, we can make a line, right? So let's do that. You could also find your slope if you really wanted to, right? Because we have 2 points right here. We know how to find slope with 2 points, right? We spent a bunch of time doing that. Change between 0 and -4 is 4. Change between -6 and 0 is 6. So -4, 6, otherwise known as -2/3 is the slope. How do we feel about graphing something in standard form? The reason we plug in 0 for this and not for this, because you could, right? You plug in 0 for x, you get 3 for y. So 0, 3, right? You plug in 0 for y, well, you do some subtraction, you get -3 for x. 0 for y, -3 for x, right? The reason we don't do that is because usually it's a lot harder. You have to do extra work to figure it out. You could do it. That's a valid way to graph anything. Plug in 0 for x, plug in 0 for y, see what happens, right? But for these, it's really nice because it like makes stuff go away instantly, right? Boom, there's your answer. Boom, there's your answer.
Wait,
Right? Yeah.
is that all you gotta do for 7?
Nope, we got to graph the other one, right? So it's also in standard form. So the easiest way to graph in standard form is to find your x and y intercepts. Could you do that in any form? Sure, but you'd have to do extra work, right? Here, if we plug in 0 for x, we get 2y equals 18. So y must be 9. And if we plug in 0 for y, we get -3x equals 18, which means x must be -6.
Intersect at -6.
Yeah, they intersect at the x-axis, or the x-intercept for both of them, don't they? So where they agree is at -6, 0. Just happens to be the same place where they hit the x-axis.
Why do you graphs go up to 12?
Why not? Instead of 10?
Yeah.
I think 12 gives you more room to play around with stuff. 10, there's not a whole lot of numbers that you can fit in there. Think about it. 12 has lots of factors. 2, 1, 6, 4, 3. That's why we used to count by 12s. But 10 only has a couple. 1, 2, and 5. Right? So there's lots more playing around you can do with the number 12 than you can with 10. But 10's more convenient because it ends in a 0, and we have 10 fingers. So we count by 10s, not 12s. 77. Well, we can take that jumbled garble of mess and put it in the slope-intercept form by distributing, right? That 3 and solving all of it. Or we can know what it means and just graph it. The top equation. 2 ways to graph it. 1, okay? I would say, look, I know what this means. That means that 3, 3 is a point on my graph, right? change the signs, right? Remember H and K? So 3 and 3 is a point. So let's graph that. 1, 2, 3, 1, 2, 3. So I know that's a point on my line. What's my slope? 3 over 1, right? 3 over 1. So I go up 3 over 1. How many points do you need to make a line? 2, right? I'm going to do a bunch more to make it more accurate because I'm trying to solve by graphing. That's way easier than doing all that distribution. Could we have done it? Sure. Distribute the 3 and then add the 3 over. We would have got slope-intercept form. We've got -6 for our intercept. We would have got 3 over 1 for our slope. We could have graphed it that way. Yeah, other one's not in standard. What is it? What form is that? It's the one with the slope and the intercept. So we call it slope-intercept form. I don't understand. Point-slope form is the weirdest looking one. Everyone remembers that name. But slope-intercept, oh God, right? But we graph it all the time. Y-intercept at -6. That's where they agree. And then 3 over 1. Not only do they agree there, but they agree at every, oh my God, they're the same frickin' line. How many solutions will they have then?
Infinite.
There you go. Infinitely many solutions because they're the same line, Isaiah. It's because they're the same line. They have infinite solutions because they intersect constantly, right?
So that's.
I didn't say anything. 78. Does that make sense, though? Because, right, we have one solution here, right? Because they intersect at one spot. But here they have infinite solutions because they're always intersecting. Does any number set work? No. This number wouldn't work. Whatever that combination is over there, whatever dot I'm pointing to, right? But any dot on this line would work, any combination on that line. Like, for instance, 3, 3 would work. 6, what is this? 1, 2, 3, 4, 5. Oh, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 9 would work, right? All of those combinations would work for both of them. But not any combination, right? Out here wouldn't work. So it's interesting. Infinitely many combinations, but not every combination works, right? Infinity's weird. 78. What's the top equation in? What form is that?
Slope intercept.
Slope intercept. It's the one with the slope and the intercept. So intercept is -5. 1, 2, 3, 4, 5. So that's our first free point, and then we can use our slope to find another, right? So we always do the intercept first, because you need to know where you're starting, and then you set your angle, right? Down 1 over 3. If I keep doing that, I end up here. And then the other one, what form is that in?
That's a nice one.
That is. What form is the bottom one in?
Standard.
Standard form.
Yeah.
So what's the easiest way to graph that? There are lots of ways to do it, right? We can get it in slope-intercept form. We can do whatever we want, right? But the easiest way to graph it. Somebody's here. A couple people are here. Hope there are people. So, what about this? How do you want to graph this one?
Do the
X and Y intercept thing, right?
yeah.
Plug in 0 for X, and then plug in 0 for Y. Well, if I plug in 0 for X, 2 times 0 is 0, so it goes away. And we get 6Y equals 24, which means Y is going to be 4. And if I plug in 0 for Y, which is what this is saying, I get 2x equals 24. So 12, 0. And that's why my graphs go to 12.
Yeah, Troy.
Oh, man. Oh, man. I have a hunch
Parallel.
that these are parallel, which means they never intersect, which means they have no agreement ever. Now, to prove that, it's hard to do with a graph because maybe the slope's just really, really small between the two, right? And it's going to intersect way off to the left or something, or way off to the right. So what we should do is prove that the slope's the same for both. What was the slope for the top equation?
-3, 1.
Negative 1 over 3.
Thank you.
No. Actually, that would be the complete opposite slope, which would make it perpendicular. The bottom one, what's going to be the slope for the bottom one? Don't say 2. It's not in slope-intercept form. 2 is not the slope. The slope would be 0 going to 4, which is what? We went 4. And then 12 going to 0. We subtracted 12. It's negative a third. They are parallel. No. I'm sorry. Yes, no solutions. No solu. No solu.
Wait, do we have to do this on
Do what?
make sure it's that?
I mean, how evil do you think I am? Am I evil enough to give you something that intersects way off your graph?
Yes. Probably.
Then you probably want to prove it, right? I find it funny you think I'm that evil. Why would I do that? What's the point of solving the graph if I don't give you a graph that's big enough to solve it? You tell me. 79. Solve each linear system by substitution. So now we're doing the same thing, but instead of graphing it, we're using substitution. Remember, substitution means switch stuff out. So if you know y equals 2, you can substitute 2 for y, right? If I know y equals 2x minus 7, then I can take 2x minus 7 and plug it in for y, right? Now, the key to this is not plugging it into the same equation, right? When you plug it into itself, it does nothing. It gets you infinite solutions every time. Why? Because it assumes that it's plugging it into a different equation that happens to be the same, meaning that they're the same thing and they have infinite solutions, right? So if every one of them is infinite solutions, it's because you're plugging it into itself, right? Infinite power. Not true, okay? Perfect.
It may be true.
Yeah, that's right. It could be, right? Solve each linear system by substitution. So we're going to get one of the variables on its own, and then plug it into the other equation, not the same one, the other equation, and figure out our answer. So for the top one, it looks really easy to get y on its own, right? Let's do that. How do I get y on its own, CJ? What do I do to get the 2 away from the y? Common answer. So we're going to stop this right now. We're not going to subtract it because it's 2 times y. Do you see it? Exactly. But for so long, you guys go doing algebra like that, and you make that same mistake. It's because no one's ever told you why you divide. They say, nope, you divide, and you go, oh, okay. Right? How do I know when? If it was 2 plus y, yeah, you'd subtract the 2. But it's time, so we divide. So we divide everything by 2, CJ, and so when we do that, we have negative 8 divided by 3 already there, right? Are you with me? I have negative 8 divided by 3 already there.
8 over
But I need to divide it by 2.
6.
So I can either divide the 8, which I'm going to do, and make negative 4 thirds, right? If I have 8 thirds and I cut it in half, now I have 4 thirds. Does that make sense? Okay. And then the 6 divided by 2 is 3. When we divide everything. So we divided this by 2, that by 2, and that by 2. Okay? Yes?
Could you also divide it so it would be 8 over 6?
Yeah, and when you reduce it, it'd be that.
But
Mhm.
you wouldn't do that for this problem.
Nope. You could have 8 over 6 there. That's fine. So now I know what y is. It's this, right? It's a bunch of junk. And I'm going to take that bunch of junk and plug it into the other equation and see what happens.
All right.
Yep. As long as we're all on the same page, you plug it into itself. Yes. So when I plug it in, I wrap it in parentheses. Can't hurt if you know what you're doing, and we'll save you a lot of little mistakes. There we go. So CJ, fractions are division for lazy people. So what this is really negative 4 divided by 3. If we times that by 3, well, negative 4 divided by 3 times 3, well, it's just negative 4, right? Does that make sense?
Yeah.
Okay. Another, what?
During the first time we went through this, I'm pretty sure I felt the same halfway through.
Yes. So 3 divided by 3 is 1. 1 times negative 4 is negative 4, so that's another way to think of it.
I know.
Or you could do 3 times negative 4 and get 12, and you divide that and you get negative 4, right? Same thing. So that's negative 4x, but we need to distribute the 3, so it's going to hit that negative 3 as well and make negative 9. And if you think about it, we're taking this and adding it to itself 3 times. Negative 4 thirds x minus 3 plus negative 4 thirds x minus 3 plus negative 4 thirds x minus 3. Well, that's 3 3s, 9. And 3 of those guys, 4. Another way to think of it. Now we're going to do some math. Get our x's together. Terrible idea in real life, great idea in math. Look, negative 4x plus 4x is already on the same side. If I had 4 plus 4 on the same side, you just add them, right? We're going to do the same thing here. That's 0 x's, so x goes away. And we get negative 9 equals negative 12. No solution. When does negative 9 equal negative 12? Never. Right? Could you move the negative 9 over? Sure. You get 0 equals negative 3. Still no solution, right? So what does that mean these lines must be? Parallel. They never intersect, so they're parallel, which means they have the same slope. So that's interesting. They both have the slope of negative 4/3, x. And would have different y-intercepts, because if they had the same y-intercept, they'd be the same line, same slope and intercept, right? But if they're same slope and different intercept, then they're different lines, no solution. 80. Look, y is already on its own for us. Yay. That's convenient. Thank you, Mr. Mack. Let's plug that into the other equation. Yes.
Hey, it's just like the other one.
Distribute the negative 3. Negative 3 divided by 3 is negative 1. Times 1 is negative 1, so that's just negative x.
No solution.
X and x goes away. So we get negative 5 equals 9.
No, negative.
No solution. Or 0 equals negative.
15.
Why? Oh, yep, you're right. Doesn't matter. 15 equals 9, never. So no solution. All right, so the key for that one, since we already know the no solution thing, how do you feel about distribution? Good? How do you feel about negative 3 times the third being negative 1? Not so good? Let me show you. You missed the first half. Okay, it makes sense because a third of 3 is 1, right? But imagine you didn't know that intuitively, right? Here's why it is. So you can either times by the top or divide by the bottom first. Let's times by the top. Negative 3 times 1 is, what's negative 3 times 1? Divide by 3? Good. Other way we could have done it. Negative 3 divided by 3 first. Times 1? Right. Okay. That's how you deal with stuff like that.
That makes sense.
Yeah. Times by the top, divide by the bottom. Your choice of which one you want to do first. You just got to do both of them, right? Okay. 81. It says solve by elimination. Okay?
I like this one.
Guys, it's after 4 o'clock, so if your parents are picking you up right now, they might be here. Okay. Are you good?
How long is this gonna take?
However long you guys want it to.
I don't know.
I'm here until at least 6. Because Heaven Lewis said that she might need help, and then so did Schlaffer, but he left. Other people have said they might need help. We've got a lot more. A lot of it's more recent stuff.
Yeah. This is like everything that's on the test.
Everything that could be, yes.
No, like everything that was just.
Oh, yeah, yeah. Remember, the way I make it is I slap all that stuff together.
Yeah,
Yeah.
what we're finishing up right now
Yeah.
is all on it.
I like combination.
Let's do combination. Remember, we need everything on the same side, and x and y's lined up.
Just subtract it.
Yep. So what I'm going to do is I'm going to take that top one, and I'm going to make it y plus 7x equals negative 5. I moved over the 7x, yeah? And I've got y plus 2x equals 5 on the bottom.
For a second, you sounded like you're. Yeah.
Ja?
Did this, yeah.
Is ja a Canada thing? I thought ja was like a German thing.
No.
Canadians
No,
like
it's
a boot.
Canada.
A is the Canadian.
Canada.
So now that we have the y's and x's lined up on the same side of the equal sign, we can ask ourselves, if I add or subtract right now, would things go away?
What? Yes.
Yeah, if I subtracted, my y's would go away, right? That's why we call it elimination, right? So we subtract them. Y minus y is 0, goes away. 7x minus 2x is 5x, equal sign. Negative 5 minus 5.
Negative.
Very good. A lot of people say 0. X equals negative 2 by division. Now we have to go find y, because we found 1/2 of the solution, right?
Does it matter which one you put it in?
No, because now we know that they agree at negative 2 for x, right? So it's like when we graphed earlier. Both of these we knew agreed at 1, 2, 3, 4, negative 5 for x. Oops, sorry. Negative 5 for x.
Oh, okay.
But now where do they agree in the y direction, right? So it doesn't matter which one you plug it into. It's going to give you the same answer, right? It's where they both agree. So if we plug in negative 2, which one do you want to plug it into, the top or the bottom?
Let's go bottom.
Okay.
Oh wait, no.
Top would be easier because when we do all this, it gets us y. Here, when we do stuff, we have to move it afterwards. So let's plug it in here. So plugging into the top equation, we have y equals negative 7 times whatever our x was minus 5. Well, our x was negative 2. So now we do math. Negative and negative makes a positive, so we get y equals 14 minus 5, which means y is going to equal 9. That's right. So they must agree at negative 2, 9. Yay! Combination's great when it works, but other times it's like, oh my god, I have to multiply everything a million times to get them to match up, and then it's awful. Please make this gone, Mr. Mac. I don't want to have to do this on the test, and I go, okay, I have mercy upon you, and I cancel it. Right?
Sweet.
But it doesn't mean it's not solvable. It just means it's really hard to get the right combination, right? That's why they call it combination. So, want to do the next one? Yes or no?
Yeah.
Of course. So, no.
I'll probably just rewatch the.
Rewatch it or show up for Tuesday's review.
I'll probably show up for
Yeah, do it on Tuesday. I would highly encourage you guys to
I
do
don't know
both.
what I'm doing Tuesday.
I might.
I'm looking at me today.
Algebra was very relaxed. You guys also almost all showed up like an hour late, right? Like ish. So if we had an extra hour, not you, but you were working on your test, and so was Baker for about an hour, right? So if we had the full time, we would have gotten through it. Geometry tomorrow is going to be like, okay, we can't do all of these.
I woke up like an hour before I got here.
And it will be high pressure, let's go, super fast review. For you guys, you have 2 days, so take advantage of that. Okay?
I had Subway.
Me and
Gonna be
Logan-
fine. Feeling good, feeling fresh.
Me and Logan won't be here Tuesday.
I know, but you can watch the review, both of them. That's what I would do.
Or you can just finish this.
Yeah, right? Or work on it, and if you feel great, then you're great, right? So, you want to see more linear combination, or we feel great about combination? Yeah, 82. All right, so for this one,
I just want to see the answers since I did it.
everything's almost lined up, but not quite. So I'm going to move that 5y and the 3x. And they're just trading spots. I didn't move them to a different side, right? So I keep them the same. And then we have 10y minus 6x equals 60. Well, you'll notice if I times the top by 2, they all match up. I could also divide the bottom all by 2, right? How about we do that? Numbers smaller is good. So let's divide the bottom all by 2. And so what I get is 5y minus 3x equals 30. And what should you notice immediately about this?
It's the same.
They're the same equation. No matter what form they're in, if they're the same equation, then they're the same frickin' line. Which means how many solutions?
0 equals 0.
Right? Because it's the same line. Same line means they're always intersecting, which means they always agree. So infinite possible agreements, infinite solutions. Parallel means they never intersect, so they never agree. Does that make sense, Isaiah?
So on those, you don't have to make it like cancel out.
Well, when you do, what happens, right? We get 0 equals 0, which is true all the time, right? 2 equals 9, no solution. 0 equals 0, infinite. Because it's always true. If you got 2 equals 2, always true, infinite. 5 equals 5, right? Batman signal equals Batman signal, whatever. I'll take a Q, another Q, another Q, Z, and then a Batman signal. I'm sorry, Peter. None of those were in the puzzle. You guys ever seen that Family Guy episode? It's one of the few funny Family Guy skits I've watched.
I don't watch.
You shouldn't. It's awful. It's not funny. South Park, usually hilarious, especially the old seasons. Not that I'm condoning it, but if you're going to watch a Family Guy-esque thing, watch a good one, right? Want to do 83 or no? Let's do it! All right, so top one. Need to rearrange it a little bit. 3y plus 4x after I move that over is going to equal 29. And the bottom one is 5y plus 3x equals 30. So we need to multiply top and bottom by something to get them to match up, because nothing does right now.
Small. 3 plus.
What?
Small. The X is
4 and 3
small.
goes
So you do
12.
that.
Yeah, x is smaller, so we should probably use 4 and 3. That's a good idea. So let's multiply the bottom by 3 and make it 15y plus 9x equals 90. And again, we're multiplying by 3, not adding 3. And then we're taking this, multiplying by 5 to make 15y plus 12x equals 145. Then, do we subtract or add to make things go away? In this case, subtract, right? 15 minus 15 goes away.
Oh, I negated it.
Negated the whole thing?
The whole top one.
That works too.
No. Well,
Then you can add them, right?
I got what?
Oh, I did 29 times 5, didn't I? I need to do 29 times 3, which is going to be 60 plus 27, which is 87. Yep, that's right.
Yeah.
Thank you. 15 minus 15 is 0. 12 minus 9 is 3x. And 87 minus 9 is negative 3, which means x is negative 1. And then we find the other part of our solution. I'm going to plug it in here. We get positive 4 plus 29, which is going to be 33. And then we divide that by 3, and we get 11. How do you like them apples? Yeah?
Oh, yeah.
I just plugged it into the
It's
top.
completely different anyway.
Did you get the right answer?
That's what I got figured. 120 minus 87.
120 minus 87 is not 11 or negative 1. Why'd you get 120 down here?
I gotta work on it.
You multiplied everything by 4? Oh, you did 4 here and
No, I gotta
and
use that
5 in the
and
top.
then divided by 18.
120 minus 87. 3 to get to 90, 10 to get to, so 33. Divided by what?
18.
That doesn't come out evenly.
No, 120.
33.
29 times 3.
60 plus 27, which is 87.
87. 30 times 4 is 120, right?
Yep.
Oh, you did.
I don't see where I messed up.
You
Let's
did
see.
the other way where you.
Yeah, I figured. Move over to the 4x. Solid. I like your handwriting. And then we double it. No, oh, wait. You doubled the top, it looks like here. But then here you times it by 3.
Oh, I doubled it?
Well, here you doubled it. 3 and 6, right?
I meant
Yeah. Just make sure you do it to everything the same. That's probably the number 2 mistake. All right, 84, any method, so you just use any method. Moving on. 85, page 28. Now I have two numbers, the sum is 2 and difference is negative 7. Want to see how to set that up or no?
Was it? What, 85?
Page
I
28.
know how to do that. Those are pretty easy.
They are. Sum is 2 and difference is negative 7. 85? All right. Let's do 86. Difference of two numbers is 6, so we have two numbers, x and y, right? And the difference between them is 6. And we know that their sum is 16. Well, because they're in standard form, we can solve them very easily with elimination, right? That's why we call it standard form, because it's a really easy way to write an equation. Now it makes sense. I'm Mr. Mac. I'm not a real math teacher. All right, so we subtract them both. 0, negative 2y, and then negative 10.
Why would it be negative 1?
Negative y minus y is negative 2y.
No.
X minus x is 0.
I got x. Because I
Oh,
didn't do
but you're
negative.
good, right?
Yes.
So that means this is 5.
5.
Y is 5. What is
Y.
x going to be?
No. X is 5.
Well, it depends. Well, x and y are interchangeable in this problem, right? It depends on how you look at it. So it could be 11.5 or 5.11.
I'm just going to restart.
Really doesn't. No, it's fine. It doesn't matter either way. Because it's two random numbers. We don't know which one's bigger when we start. I said bigger number was x, because when you subtract y, you get 6. Maybe you said bigger number is y. Great. Right.
5
Two numbers.
1, 6. Negative 1. Right?
What?
I got x minus y, 6, x plus y, 16. Right?
Yeah, then what'd you do?
2x.
Oh, so you added them. So 2x and 0. So 2x equals 22.
Yep.
Which
that's
means
what
x
I
is
got.
11. Yep.
22.
22. On the first day of ticket sales, the school sold 35 student tickets and 40 adult tickets for a total of $270.
Yep.
You want to do that one or no?
I got that. I just messed up.
Great. We doing 87 or no? You sure? Okay. You want to see it?
You just do 35.
35S plus 40 adult tickets equals 270.
It's a simple.
43S plus 56A equals 366. And then you solve.
Learn you do what you did every year. Every year.
88.
Standard form. 88. 88. Okay. A boat traveled 100 miles downstream and back. I love this problem. Makes you think.
Well, I know.
So one way it went 50, and the other way it went 50. The trip downstream took 3 hours. So downstream speed times 3 gets us 50. And then 5 times our upstream gets us 50 as well, right? It's traveled the same distance. Now, D is our downstream speed. What does our downstream speed consist of? The boat speed plus the current, because they're working together. And our upstream speed is our boat speed minus the current. So I can take B plus C and plug it in for D, and I get 3 times the quantity of B plus C. And I can take B minus C and plug it in for U, and I get 5 times B minus C equals 50. How do you solve a problem like Maria? Distribute, get in standard form, solve.
Yeah.
Okay, let's do that. So we get 3B plus 3C equals 50. And we get 5B minus 5C equals 50. Honestly, doing that requires a lot of work because you can multiply the top by 5 and the bottom by 3. What I would do is I would divide the bottom by 5 here and get B minus C equals 10. Solve for B, and then plug in. I'd do substitution. I'd divide, and what I'd do is I'd divide by 5 and get 10 here, and then solve for B by adding C. So B equals 10 plus C, and then plug that in here. 10 plus C times 3 equals 50. So 10 plus C is 10 plus 2C. 30 plus 6C. Subtract 30. 6C equals 20, and then you get your answer. It's going to be a fraction.
Okay.
Did I do that right?
Let me just solve it this way. So we're going to times this by 5, and we get 15, and 15, and 250. When we times this by 3, we get 15, 15, and 150. If we subtract, they go away. Here, they're 30. And we get 100. C over 100. C is 100 over 30.
Oh.
And then you go back and plug that in, right? Find out B.
No, you cancel out the C's, not B's.
Or
Well, I subtracted. You probably added. Depends on which one you make cancel.
Yeah.
Yeah. If you added, then you would have gotten B equal 15B. No, 30B equals 400, which means you're getting 4/3 or 40 over 3.
I saw that right.
Yeah, you'll get that for C.
No, I got that for B. Because I did.
You switched your C and your B's.
No, I kept the C's the same. So I had one negative and one positive. I just.
Added them and got 30B
Yes.
equals 400, right?
Equals 100.
Why would you do 100? Yeah, but you added them, so you should add 250 and 150. So you did like my way and your way, and the only reason you got lucky is because they're both. Well, you found the answer for C, even though it said it was B. You just got lucky. So Isaiah, if you're gonna do it your way, you were adding it. And that means these go away.
Yes. So I got
30B,
30B.
and then 250 plus 150 is 400. Yep. If you're gonna add, right? You subtracted over here.
I didn't multiply.
You also did. Oh, you didn't do that too. That's another way that could have happened.
Yeah, I
Yep.
didn't multiply 50.
Yep. So you got really lucky then. Yeah.
can we do like one of these? 9,
Give me a number.
like 90.
Yeah. That's where we're heading to next. So 90. It's graphing the equations and then choosing which side to color, right? So imagine they're equal signs. Unless you divide or multiply by a negative, in which case you have to remember to flip the sign, right? So in general, let's get y on its own so it's slope-intercept form for the top one, right? So I'm going to divide by 3, and I don't have to change the sign when I do that, right?
Oh. Hello?
That's true.
Math?
Yeah, but he's probably here to pick you up, right?
Yeah. Oh, well, we're going over to finish the thing. Alright. Alright. Bye.
So the first one I got in slope-intercept form, so I could graph it easily, right? Y-intercept of 3, up 1 over 1. Is it solid or dashed line?
Solid.
Isaiah, are you with me? I divided everything by 3.
Yes, I had that.
Good, and I didn't have to change the sign, right? Good. Now, to figure out which side I'm going to color, I try 0, 0, because it's not on the line, and I plug it in. Is 0 less than or equal to 3? Is 0 less than or equal to 3? Yes, so we color the side that has 0, 0 on it, because it worked for the blue. Okay? Cool. So that's where the solution is. Now, for red, it's going to have a solution. Let's graph this. What form is that in? Standard. So let's just graph it by finding intercepts. Plug in 0, right? So we're going to get 0 for y and negative 7 for x. So 0 for y, negative 7 for x. 1, 2, 3, 4, 5, 6, 7 to the left. And we're going to get 0 for x and negative 7 for y. So 1, 2, 3, 4, 5, 6, negative 7 here. Are you guys cool with me getting those numbers and how I got them? Negative 7 for x, negative 7 for y. It's a coincidence that they're both the same numbers. So make sure you write it down and don't get them goofed when they're not. So solid or dashed line? Dashed, because it doesn't include the line.
What's the y-intercept?
Y-intercept and x-intercept are both negative 7. Now, which side are we going to color? Try 0, 0, because it's not on the line, right? You can try any point as long as it's not on the line. And if I plug it in, 0 plus 0 is 0. So 0 greater than negative 14? Oh, yeah. So the red agrees here. And here. On the right side of the red line. Notice where they agree. It's kind of easy to tell, but I'll color it in purple just in case. So they agree all through here. So any point in here, any combination of x and y in here, would work for both of them. So that is the solution area. Any point in there works. Not including the red line, but including the blue line. What do you think?
I was gonna ask a question back.
That's the idea. Now, if we divide or multiply by a negative, remember to flip the sign so you color the right side, right? But other than that, that's it. Test a point that's not on the line. Figure out which side you color, right? 0, 0 is a good point to test if it's available, right? If it's not on the line. Because zeros make things go away. And that's the whole point of math, is to make people and things go away. Mr. Mack is buying pizza and cookies for a party. Do you want to do this one or no?
Do the
Yeah, which one? The one on the test? Yeah, which one's that? 93. Good idea. Jordan needs to spend at least 2 hours doing homework, but she also wants to hang out with Olivia. So, homework hours is one of the variables, right? How many hours she spends doing homework. So I'm going to call that H. H needs to be at least 2 hours, so greater than or equal to 2. You with me?
Okay.
She also wants to hang out with Olivia, so we got Olivia hours. So I'm going to call that L for Livia, okay? Because O's look like zeros, even though I put a slash through my zeros just for that reason. So L says she needs to spend half an hour more hanging out with Olivia than studying.
1/2 each. No.
No. 1/2 up.
No.
So spend half an hour more hanging out with Olivia than studying.
So 1/2 plus.
So the amount she spends with Olivia has to be the amount she does studying plus a half. Studying and hanging out with Olivia must total under 8 hours. So, studying, H, and Livia time, L, must total under 8. All right. So those are our restrictions. Some are equal signs, some are less than or equal to, right? So let's make an H axis and an L axis since we're not using X and Y. So I'm going to zoom out. So let's make this the H axis and this one the L axis. Okay? You could flip it. Then your graph would just be flipped, right? So we know H has to be greater than or equal to 2. So here's H. Here's 2 on H. Greater than or equal to, so it's going to be a solid line. You dig? Now, greater than, here's H. Which way is greater than? To the right or the left?
Right.
So it's going to be this side, including this line. Does that make sense? Those are possible times for H, so homework times. Now we also know that L equals H plus a half. So H is kind of like our X, so that's kind of like our slope. We have a half at the y-intercept, and then we go up 1 over 1 from there. Ugh. Whoops. Here. Just keeping it in the middle. Sorry, my dots were wrong at first. I know, annoying, isn't it? How do you feel about that? Now it has to equal that, meaning this is a solid line and there's no coloring needed. Do we agree? Yeah. Okay. So right now, where those two things agree is here. Just where it's colored in and on the line. So anything that's on the line from this point on is a possible answer. Nothing out here works anymore, right? Yeah. Because it doesn't include part of orange, right? But these are all correct. Nothing here works. Then we also know H plus L is less than or equal to 8. Now, what form is that in? This guy? Yeah. So L equals H plus a half. So half is our y-intercept. H is our x, basically. So that's our slope of 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. Right?
But you didn't need to color in any others.
No, because it's an equal sign. That's where all the answers are, on this line. When it's this, it's saying it's all the answers on this line and anything bigger than that, right? That's what it means. We colored in just the line. That's what a line is. It's just very thin colored in area. Okay? I graphed it just like it was a line, because it is. That's where all the possible answers are to fit this, and they're on this line. All the possible answers for this are on this line and anything bigger. And so where they overlap is here. H plus L equals 8. If we were to write equals, it would be in what form? Standard, right? So we're going to have two intercepts, really easy, 8 and 8, right? So intercept at 8. I'm going to do that in red. Intercept at 8 for H. 1, 2, 3, 4, 5, 6, 7, 8. And intercept at 8 for L. 1, 2, 3, 4, 5, 6, 7, 8. Solid line or dashed line?
8 for both? Solid and Y?
Yeah, well, 8 and 0 for H, right? If I plug in 0 for H, I get 8 for L. If I plug in 0 for L, I get 8 for H, right? Isaiah, do you see why it's that? Plug in 0, 8. Plug in 0, 8. Right? Okay. Solid line, because it's less than or equal to. Now, this one you might be able to guess, less than or equal to is this way, right? But if you're not sure, plug in 0, 0. It's not on our red line, right? 0, 0, less than 8. Yes, so it's going to be this part that's red. Anything down below the red line. And where they overlap is kind of hard to see, but it's going to be right here, and I'm going to do it in blue. Right there on the line. It's not an area, it's just that little bit of line.
4 and a half? No.
That little blue part of that line is where they agree.
So in between the 4, 4 and a half and the other one?
in between the H line and the red line on the orange, right? Right? So lines are weird because they're just on that line is the answer, right? So only that little bit is where they overlap. It's not an area, right? It's just that part of the line. Does that make sense? Okay. It's kind of a weird concept that I never knew about in high school and didn't make sense to me. But if you know what it means, it's like, of course, right? It's kind of weird, but it really makes a lot of sense, right? Just from here to here is a possible answer on that line. Cool. Not so bad, right? The half was the hardest part, and that's not hard. It's just weird.
96.
You want to skip 94 and 95?
You do 96?
Yeah, 96. Yeah, basically, right? 96. The farmer has 30 feet of fencing for an enclosure next to a river. She wants to maximize the total area of the enclosure, eliminate at least half the possible lengths using a system of inequalities. So, first off, I'm going to call this part X and this part Y. And if you can imagine, those varying create different types of triangles, right? If X is really long, then Y has to be really short because we're out of fencing, right? And if X is really short, then Y has to be really long. Or maybe they're about the same, right? You can kind of imagine all different variances of the triangle as X and Y slide. So I put this into Desmos, and I did to make a triangle and all this other crap. And if I took X and Y and put them on sliders, you'd be able to see them doing that type of thing, which would be pretty rad, right? All possible variances. Now we know that X and Y, when they add up, have to be what?
Greater than 0.
Well, X and Y individually have to be greater than 0. So that's good. We'll write that down. X should be greater than 0, and Y should be greater than 0. And we know X plus Y has to be what?
Equal 30.
Equal 30?
Or less than or equal to.
Yeah, he could use less than 30 feet, right? Which makes the problem a little more complicated. He might just want to say, farmer, just use all 30, right? But it's fine. So now's where things get weird.
Yeah.
Should we use graph paper for this instead of just freehanding it? Let's do it. Okay. What?
Can I do that?
Oh, please, yeah, of course. So, zooming out. Let's make a coordinate plane. This is, I know, it's because it's short. Wait, nope, it's shorter this way. Nope, are they the same length, top and bottom? I think they have the same margins, top and bottom. I was trying to get a smaller margin here, but I think it's the same. Yeah, I think it's the same on both. It looks smaller. That's why I flipped it. All right, so let's draw a coordinate plane. Actually, let's be smart about this. X and Y are greater than 0. So do I need all 4 quadrants? No, I just need the 1. So let's do that. Now it is upside down. I'm just making it extra big to make sure I'm good to go. I could literally do 30 and 30. That'd be kind of nice. Like 30 up here, 30 over there. I could have done that. Let's do that. Let's make it as accurate as possible. You could count by 2s if you wanted. I'm going to do 30 and 30 just for fun. So, 30 from the top.
Do we have to have a graph on the paper?
Nope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, oh no, 28, 29, 30. Guess what? It's not going to be 30 this length, is it? Nope. It'll be close. It'll be close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, I believe. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh, yes. 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 Beautiful. Let's mark these up by 5 so we can see what's going on easier without having to mark every single one. Because it takes more time. Yeah. Oh, yeah. Oh, yes. probably do the blinds just in case one of those other students shows up. They can see that I'm in here. Hopefully not.
It's dark out.
Yeah, what?
Why is it so dark?
Winter.
It's only so
I'm gonna do one. Might as well. I just don't want people sitting out there thinking, oh, Mr. Mac, I couldn't get in. Like, yeah, you could, you dummy.
Just go through the window.
All right. How those portfolios coming, boys?
I need to start mine.
Yeah, do you need more homework to fill it out? I have stuff there and there. I don't know if you've gotten all your stuff yet, but
I
it's
got
there.
like three tests I'm gonna use.
Good, good. Make sure you write about them, right? Don't just stick them in there. Make sure you type up like, here's test 1, here's what I went wrong, here's what I could do better, here's what I learned from this test.
Oh, another thing is, can I do like bullet points talking about it? Like it'll be a bullet point and then it talks about it and then.
Yeah, that's fine. Yeah, if you give it like bullet point paragraph.
Yeah.
I don't want just bullet point like blah, 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 right? I want like, yeah, thorough analysis here,
Yeah.
okay?
Troy, just send me yours. What? Just send me your portfolio.
This is beautiful looking, by the way. Look at that, look at that. Isn't that right?
Can I see one of those people for the portfolio?
You probably don't.
I do. I don't have the other bit.
The other bit.
I don't think. I might have thrown it away. Do I have any more of these anywhere? I can print one out before you leave.
I don't need it. I just want to look at it. So you don't.
Let me print it. Let me print it. Let me print a bunch.
You probably won't need it.
Yeah, I do.
Oh god.
Portfolio.
Sorry.
Sorry.
Taking. Yeah.
I'm awake now. I get re-kicked in.
Nice.
Uh-huh.
All right, so that's sending to the printer. By the time we're done, it'll probably be ready to print. Okay, so let's do this thing. We know that x and y have to be greater than 0. I did that by limiting myself to the first quadrant, right? Now we've got x plus y is less than or equal to 30. So what form is that in? Standard. So it's easy to find intercepts. Our intercepts are going to be what? 30 and 30, right? 30 for 30. ESPN special. Yep. So here's 30, right? And here's 30, which is why I made mine 30 by 30, right? So we know that the line
Luckily.
is going to be, where's Saddam? Ah. Right. So from here to here is our line. This is our line that contains all of our possible solutions,
Yes.
like 25 and 5, like 10 and 20, right? We want to eliminate half the possible solutions. Right now, lots of possible answers. We know the outsides don't count, right? Because 30 and 0 wouldn't work. We wouldn't have a triangle, right? So first we need to figure out what the total length is, and then we can try and figure out what half is and try to get, a lot of stuff eliminated. So here's what I would do to be as efficient as possible. If this is the right triangle, and it is, we should be able to use Pythag, right? Pythagorean theorem. So we have 30 squared plus 30 squared rooted is going to be the length, right?
Write that on the paper.
What? Could you write it?
Not the triangle. What you're writing right now.
Could you? Yeah, why couldn't you? Are there rules against this?
You want.
Yeah, well, you need to figure out how long it is so you can figure out what half is, right? Because we're never going to get the exact perfect answer. Spoilers, it's 15 and 15. But without calculus, or it being really obvious, right, you're not going to be able to figure it out. So you'll just be able to eliminate, like, I know my answer is somewhere in here, right? That's what we want. So the total length is 30 squared plus 30 squared, which is going to be 900 plus 900 rooted, which is, of course, 1800 rooted. So half of 1800 rooted.
What does even rooted mean?
Great question. So,
They always talk about this. And
Right.
I don't know what it means.
so thank you for asking. Nope, I got this. So check it out. Check it out. These are called operations. They're things you do to numbers. plus. What undoes addition? Subtraction, minus. What undoes multiplication? So there's a way to undo and redo stuff. That's what algebra is all based on, right? This idea of undoing and redoing. Then we also have squaring. So I need a number, so I'm going to use a as my base. Okay, so squaring a number. And then to undo that, you would root it. They undo each other. So this is saying what number times, this is saying number times itself, right, basically?
It wouldn't be a under that.
It wouldn't be a squared to cancel it, technically. It would.
See, even you don't.
No. I know what you're saying. I get confused about how to represent this all the time because it's a little tricky because it's not 100% accurate what I'm doing here. But it is if you follow the logic there. So a squared and rooting a, those undo each other, right? It'd be rooting a squared. Exactly, right. Yeah, to undo it. But I didn't put any variables here. If I had, I'd have to do crazy stuff as well. But which is part of it. So they undo each other. A squared means, well, we learned today it's 1 times a, right? Is what's going on here. The root is saying, what number times itself gets you a? Okay? So it undoes that, right? So 4 squared is 16. But then when you root that, 16 squared, or the root of 16 is 4. So it kind of works backwards, right? That's all it means. There are cube roots. We just don't put the 2 here because it's just assumed that it's a square root. There are 4th roots. There are 5th roots. And all they're asking is the opposite question, right? So like 2 cubed is 8. So cube root of 8 is 2, right? Yeah. Thanks for asking. And when we square something, we literally mean square. You're going to learn this in geometry. 2 squared means 2 on a square. What's the area of a square that has a side length of 2? 4. Otherwise known as 2 squared. Why do we call it 2 cubed when we do the 3rd power? 2 on a cube. The volume of cube. 8. When its sides are 2, right? Okay, so anyway. Triangle, that's the length of the line, because that's the hypotenuse, right? So we need half of that, and if we can get under half of that, then we've won. So here's what I'm going to do. I'm going to test 15, 15 right in the middle, right off the bat. So let's test that point. We want to maximize the area, and the area of a triangle is half base times the height. So there's our base, there's our height. So we're doing 15 times 15 divided by 2. What is 15 squared? 15 times 15. No, that's 15 divided by 2. So let's do 15 times 15 in our heads. What's 15 times 10? And then 15 times 5. We're going to add those together, right? 15 times 5 is 50 plus 25, which is going to be 75. So we have 150 plus 75. So the area would be 225 divided by 2, right? Because we have to have it because it's a triangle, right? So if we find a bigger answer than that on either side, great. Then we can start eliminating stuff. Spoilers, we won't be able to, right? At least I don't think so. How about we try 20 and 10 on this side? So we're going to try this point. Boop. What would the area be for that? 200 divided by 2, which is 100. I'm going to leave it like this because it's easier to see that that's bigger when I have it like that, right? I don't have to do any thinking. 225 is bigger than 200, right? Okay, cool. So we know that's smaller. If we find another smaller one over here, then we know that all the small answers must be there. There might be a bigger answer between the two, right? We don't know that. But if there's a smaller answer here, then it's all small all the way down. Does that make sense?
So that means we can just eliminate.
You can eliminate, right? It's all going to be worse answers this way. If we find a bigger answer over here, then we know bigger answers might be this way, and then smaller answers must be between here, right?
Yeah.
So let's try 25 and 5. That's going to be an area of 25 times 5. Well, that's 125 divided by 2. Now, is that smaller than all the rest? Oh, yeah, definitely, right? So guess what? We just eliminated all of the answers between here and here. Are we half as big as we were before? Probably not, so I'm not going to stop. What I'm going to do is I'm going to try to eliminate the same amount. So I did 20 and 10 here. What if I did 10 and 20 here?
Probably the same.
It would be the same, wouldn't it? Because it doesn't matter which leg's which, right? So the area, of course, is going to be 200 divided by 2, right? And if I test this point, 5 and 25, isn't that going to be the same as when I tested 25 and 5?
Yeah.
So area is going to be 125 over 2, which means I can eliminate all of this. I bet that's less than half or exactly half. So let's try it out. I could get smaller to be sure, but let's figure it out. How would I know what length this is? Well, if you notice, I can make that into a right triangle as well. How long are the legs? How long are the legs? 10, right? So we take our x's and subtract them from each other. x2, x1, 20 minus 10 is 10. Here, between 10 and 20. 10. So what's the length of this? Well, it's 10 squared plus 10 squared, which is 100. Added together, that's 200, rooted. So this length right now is root 200. Is that going to be less than half of root 1800? Now, we're going to estimate this. Root of 100 is what?
50, no, 20, no.
What number times itself gets us 100?
No.
10, right? So 10 is root 100. Root 200 isn't going to be double that. No, because 20 squared is 400.
15.
So we know root 100 is 10. We know root 400 is 20, right? So this must be between 20 and 10, right? So let's say approximately 15. It's not, right? We know what 15 squared is. It's 225.
Yeah.
But it's approximately 15, right? Okay. So what's this approximately? Ooh, tougher question. What's root of 1,000? 100 times 100 gives us 10,000. Darn. 1,000's not a nice number.
It's between 10
What's another one?
and 100.
50.
Here's what we should do. Don't estimate this one. We know that this is half. If this is half, we win, right? So if I square 15, right, I get 225. Okay? If I square 30, I'm going to get a number that's twice as big, right?
Oh.
Actually, hold on. Yeah. What am I saying here? What do I want to do? There's a better way to do this. I'm losing my thought. There's a lot of meta going on here because it's all estimation of estimation of estimation. Instead of estimating this, we know this is how long this is, and we want to know, is this half of this? Well, if we doubled this, then we would get 2 times root 200, which is going to be about 30, right? So if this is 30 and that's 15, eyes up here. If this is 30 and that's 15, haven't we cut it in half? So the question we should be asking is root 1800 less than 30? I'm sorry, bigger than 30, because if it's bigger than 30, then this is already half of it, less than half of it, right?
No.
If it's 30 exactly, it's half of it. If it's less than 30, right, it's only 20. Well, that's 15. We haven't cut half off, right? So we need to know, is this greater than or equal to 30? Because if it is, then we're done, right? So is this greater than or equal to 30? Meaning, what number times itself gets me 1800? Does 30 times itself get us 1800? Because if it does, if it's less than that, then we win, right? But if it's more than that, then we're no good. What's 30 squared?
9,000.
900. Is 900 less than 1800? Oh, yeah. So we have way less than half here. We have about a quarter, right? So that's fine. We can stop there. We can say, we know that our solution is somewhere in there. Spoilers, that's the actual right answer. Without calculus, you could figure it out if you were lucky, right? But with calculus, you could have even crazier stuff going on and figure it out. Anyway, so we know we've shrunk it. So we know that our answer is between 10 and 20 for x and between 10 and 20 for y. We could have had a weirder looking triangle where they weren't the exact same numbers here and here, but we did it pretty methodically. So we know x is between here and here and y is between there and there for our answer. Does that make sense?
Fine.
What?
Find half. How do we find half?
So 30 by 30 was our line.
Yes.
It's root 1800 in length. Okay, some crazy number, right? This, when we cut it down, is only root 200, which is about 15. So we're saying if that's less than half, then we win. Well, if it was exactly half, then that means the whole thing would be 30. So if this is bigger than or equal to 30, then this line is bigger than or equal to 30, which means this is way smaller than a half, right? So I said 30 times 30 is 900. Is 900 less than half of 1800? It's exactly half, right? So we're good.
Oh, okay.
Okay? That's actually a quarter of 1,800 because it's 15. 30 would have been half, right? Because 30 squared is 900, right? Okay. So we're down to a quarter. We did it. We have the possible solutions. Our solutions are between here and here, between 10 and 20 for x and 10 and 20 for y. So how do I write the answer? I write that I've eliminated it between here, and I've said that x can be any number as long as it's between 10 and 20, and that's going to be our best answer, right? Y can be any number as long as it's between 10 and 20. And we're done. So the best possible answer for x and y is between 10 and 20 for both. Could we have eliminated other things and made it a weirder triangle and had like, 5 and 15 or something crazy? Yeah, we could have, right? But in this case, I was methodical, so it's both 10 and 20 for both. I could eliminate even more. Keep going, keep going, keep going, keep going. That's going to be the best answer in this case. More complicated fence, you're going to have more complicated answers. It's not going to be right in the middle, right? And that's where calculus really needs to come in, because otherwise you're guessing in the dark and you may never get there because there's infinitely points to try. Calculus is like, boom, there's the best answer, which is sick. Sick. Complex problem, all these different things. I need this for this much and that for that much and this much here, and they can't exceed more than this. And calculus is like, boom, that's the best possible answer. Makes everybody happy. It's like world peace right there. France needs this, Germany needs this, America needs this, Japan needs this, Kuwait needs this. Calculus, boom. Here's the compromise. The problem is that no countries want to compromise. No one wants the best answer for everyone. They want the best answer for themselves, which is why John Nash invented this idea of game theory, of how we get the best answer for everybody, and it is through compromise, not competition. This is not old science. However, no one wants to agree to it, which is why communism, as great as it is, will never be fully optimized because no one wants to play by the rules. But if we did, it would be perfect. But the question is, even if we don't play by the rules, would it still be better? Calculus says yes.
Wait, is 97 the same?
Same dumb crap, right? It's with a rectangle, so our area is x times y instead of x times y divided by 2. So if we had 30 max fencing for this, right, we just not have divides by 2 here. That's it. Also, this stuff would be different. It wouldn't be 30 and 30. It would be 25, 25, and 50. So 25 for the x-axis, and then 50 for the y-axis. It'd just be a different equation. You what?
Look at
The one for the test?
Yeah.
You want that review?
No, I can just look at that. For
Oh, yeah. I see what you're saying. All right, so Troy, I'm going to get you the rubric thing, and then we'll get out of here. Or at least you will. I'm going to stay around for a while and see if anybody shows up. Also, can we just pause for a second and think about, that was the entire final. It's everything we've learned all year. Is that intimidating? All that stuff we did? Like, let's flip through it for a second.
Do you want to stop here?
No, I want to keep going. Let's talk about it for a second. The first page is kind of intimidating because you guys never really learned it the first time, and you're having to learn it for real this time.
Yeah.
But not that scary. You understand this stuff now,
It's easy.
right? It is if you know it. This stuff, a little intimidating because there's like a lot to it, but you can break it down by terms and you'll be fine. This stuff, feeling pretty good, right? More of it, more of it. Then we get to here, multiplying fractions. Feeling very good, right?
Yeah.
Solving and graphing inequalities. Basic ones, super easy. Writing the solution set, a little weird, but if you study it for a couple seconds, and you know this stuff, you'll be fine. Right, what sets they can be in. So that's not bad. Then we have more of them. Now they just have or and between them. No big deal. Word problems, the setup. You guys can do this. You guys are good with setting up word problems. You know what stuff means. You'll be okay. Study the ones that are in here and you'll be fine. This stuff, hard to read, but not hard to do, right? Just take it slowly. Raise your hand if you have questions. What is slope?
Is all of this going to be in the?
All of it can be. Not every single question, right? I'm going to cut it down by a lot. Like, will I ask about slope-intercept form and point-slope form? Probably not. I'll probably just ask about one, right? And it'll probably be the harder one.
Of course. Even though I know that one.
Although, yeah, this is the one everybody knows, but everyone goofs this one up with it, right? No one remembers the name of point-slope form. I might ask instead, here's y equals mx plus b. What's the name of it? Screw everybody over. This stuff, finding slope. Putting it into point-slope form.
Easy.
Yeah, easy, right? This stuff, easy. This stuff, easy. 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 Graphing, right? Graphing, easy. Substitution can be difficult if the numbers get hairy, but in general, you know what you're doing, right? Elimination can be difficult if the numbers get hairy, but in general, you know what you're doing. Use any method, great. We like that. Setting up word problems like this.
Pretty simple.
Not too bad if you know what you're doing. And again, you know which ones could be on there, right?
Yeah.
Graphing systems and inequalities. Same as before, now we color. Dashed line, solid line, flip the sign if it's negative, right? If we times by or multiply by a negative. Then we're here, Jordan and Olivia, reading inequality word problems. And then we're here. This is not that bad. It really isn't. You're not going to need to study for hours to get ready for this thing. Know the ones that you suck at and study those. The ones that you're good at, make sure you know the directions and what they're asking for, right? So you're not surprised when you see it for the first time in the final since you haven't been studying it, right? Just know what it's looking for, right? And then study the ones you don't know, and you'll be fine. You're going to destroy this final. Yeah. Which is an accomplishment. Anybody can destroy any final, because most finals are pretty easy. Mine are tough. You have to actually know your crap. But the good news is, you do know your crap. Right? So you'll be fine.
How's the final schedule?
You guys are 7th hour, so you are odd, which means you have your final
Wednesday?
Wednesday.
Tuesday
Is that
and
the only
Wednesday,
day where
are those the days?
we'll be able to?
You also be able to do it Friday if you need more time.
Alright, so for the needed classes, like
Mhm.
the ones we need finals for. Monday, Tuesday, Wednesday, Thursday.
Wednesday, Thursday, Friday are finals.
Monday, yeah.
Monday and Tuesday, it's just in here with me. Tuesday, we're going over your portfolio. Monday, we're reviewing in class like we did here. Just we will not have enough time to do every problem. Like, oh God, right? We spent 3 hours doing this, didn't have enough time. But we will turn in portfolios Monday, okay? And we'll talk about it on Tuesday. Let me get Troy's out.
See Troy.
All right, it's printing. Let's see if we have anybody watching the live stream that left a comment. Nope. All right, I'm ending the stream.